You want to use distilled water carefully.
Watch hail. Watch out for hail. Yeah.
Get all the
Yep.
pollen
Better
off of
than,
it.
rainwater, I think. So
We've got pollen. We've had pollen for the last month that's been off and on bad. And I know the Mark Slade Remote Observatory telescopes need to be cleaned for the pollen.
Always a problem. Always a problem where you have oak trees. Wow. It's really bad down here in southeastern central Texas. Usually it's in March though, end of February to the middle of March. Just green, everything gets green.
It's amazing how fast the leaves pop out and they just go full bloom on the trees. You know, it's like a couple weeks from nothing to full bloom, seems like.
And if you have a black car and it sits underneath the oak tree in front of your house, you'll go out one morning and it'll be kind of this yucky yellow color.
Oh yeah. It's terrible. The pollen just, and when you're driving, you see it along the hood, it looks really yellow, it's like.
I have severe allergies, so I felt the pain in all ways.
countdown going on, and we're going to share this. Your mics are hot, but that's fine. You can talk up, no problem.
So now we need to edit any further Monty Python jokes.
I remember my favorite Monty Python sketch was, of course, the lumberjack one.
Ah, yes.
I used to I used to love that show. But then it kind of got older, and by the time we got to Life of Brian, I was kind of getting out of it a little bit. But I still go back to the original, and now for something completely different from Monty Python.
That was like a secret club. I had a little, 12-inch black and white Sears TV in my room, and it was on PBS, of course, back in the day. And so you used to be able to fall asleep and, unbeknownst to the parents, stay up and watch, Monty Python's Flying Circus on PBS.
Oh, yes. Yep.
Yeah.
Be infused.
Was something completely different.
Exactly. Yeah.
In 1977, I think, PBS did a live broadcast of them. And I think it was Palin was doing something with John Cleese, and they did the Dead Parrot sketch. They were trying to get through it. And Palin just could not get through it. He started giggling, he started laughing, and he's trying to do this thing. And finally, Cleese is looking at him and he said, "This is no laughing matter." And the two of them, I just couldn't finish it. It was so well done and so good. That was a PBS sketch that I saw live with Monty Python.
Good stuff.
Now, did Monty Python do live presentations, like live stage things?
They did a few. They did a famous series of shows that were filmed at the Hollywood Bowl, in fact, that you can get, I think, on Blu-ray as live. And I always thought, it's hard. I mean, you saw those original sketches, so many times filmed in a simplistic way, on video. Yeah. And it was kind of hard for them to recapture that same spark live. I thought, they were so iconic, the original sketches,
True.
But they did some live shows. Yeah.
So
I think there were a couple of concerts as well in the 80s to honor the Prince's Trust. Do you remember that at Wembley? And I think they did some performances there as well.
Cool. I got to meet John Cleese once, and he's a real gentleman. He really was.
Is that right? I never met him.
Yeah, very nice man.
And
very tall.
Why don't you tell us about the time that you actually met Garrison Keillor at the airport, at an airport?
Oh.
Mm.
Now, I had seen Garrison Keillor and a home prairie companion at the Egyptian Theater. That's no, it was a Hollywood Bowl. It was the Hollywood Bowl, and just an amazing program to watch that whole live presentation go down and everything, Charlie Sheen, not Charlie Sheen, but Martin Sheen was there. Some other regulars on the program. So it was just really nice to watch all that. And I've always loved Garrison Keillor, but I am taking one of my business trips and I end up in Minneapolis, St. Paul Airport. Okay. And I was wearing a rock and roll t-shirt. Okay. And I come up and I'm climbing these stairs and it's just me and him. Okay. And he's standing at the top of the stairs with his arms pinned at his hips. Okay. Looking up at the sky like a statue, kind of like, and I saw him and I walk up and I said, "Are you Garrison Keillor?" And he said, "Yes." And I said, I just absolutely adore you in the show and everything. And I said, "I just want to thank you for, all those years of, smiles and entertainment and all the rest of it." And he just looks down at my shirt. He kind of like looks down in his eyes and looking at my shirt and he says, "Ramones, huh?" And I go, "Yep." That was it. That was my encounter with Garrison.
Yeah.
Yeah. I guess he was not a Ramones fan, so.
Prairie Home Companion is a long bunch of light years from the Ramones. Yeah.
Yes. Yes, it is. Yeah, it was pretty funny though. Let me see. I like to share to the dogs and cats of space and astronomy. It's just a great name for a group. Our last Global Star Party, we had over 100 shares. So that's a lot. Just on Facebook.
That's good.
Yeah.
Yeah, that was a record turnout and like a mini marathon of 7.5 hours, Scott.
Oh
That
my
was
gosh.
Pretty long.
Wow.
yeah, yeah.
It was.
Yeah. And I guess the only one that rivaled that was the Great Jupiter-Saturn
Oh,
conjunction
that was
in
the
December.
longest. Yeah.
That was a big one.
Yeah.
Yeah. I remember hearing David, on the third round there. I was like, "Oh man, you guys were real troopers."
Yeah.
It
I'm
was,
like
it was
slamming back all this
wonderful. It was
coffee and
almost a
everything.
24-hour event. It was
I know, that was
really,
impressive.
really something.
It was
I'm going
great.
to do it again for the, I plan to do it again for the next Astronomy Day event. And I want to get multiple broadcasters to join in together and see how we can do that. So I'll be talking to a friend of mine that he and I tested it before, just two separate broadcasts and joining them together. And so there may be ways of, electronically doing that. And there may be ways of just like handing off, the next, saying, "Oh yeah, and make sure you guys are going over here and you're going over there," and, this kind of thing. So, but I'd like to take a loop around the world from people that do broadcasting for astronomy. I think it would be really cool.
That would be
Certainly
awesome.
be able to get Montreal to do a part of that. I think that would be very interesting.
Oh, absolutely. Absolutely.
Yeah, Karim was excellent. And then I think Simon helped you, right, Scott, on that. He had a
did.
multicast going on,
He did.
and so that was really good.
I think that he, he just pulled in Zoom into OBS or exported a virtual camera or something and made that handshake happen. So I've got an idea how he did it, but
Cool.
But I'll pull him in as a tech advisor on that.
Yeah. Yeah, that would be really good.
Hello, John. It's good to see you down there or up there or wherever you are on the Zoom tonight. Welcome to our global star party.
Thank you. Thank you. Actually, I never know where everybody is on their respective screens because you are located right below me. And Jerry Hubbell is 3 down. Cameron Gillis is 2 down.
I think it's different for everybody because for me it goes, of course, myself at the top, David Levy, David Eicher, Cameron, John, Jerry, and then after Jerry is Richard Grace, then Don, then Libby. So. You guys are listening out there in the audience, and I know you are. Please consider sharing this event. It is an educational outreach event, and we got some great speakers for you tonight. And you're going to learn about the meaning of life in the universe. How ominous is that? So
it's really pretty simple.
Yeah.
But I'll get to it.
Yep.
You'll get to it.
You boil it down to
Boil it down to
protons,
3 words. Yeah.
protons and neutrons and electrons. You can boil it down to that. Or quarks.
I thought it might be something like chocolate ice cream.
Close.
It's not a bad start. Yeah.
And who do we have watching right now? We've got James the astrophotographer, Jeff Wives. He said, I would like to learn the meaning of life. Steve Hauser says hello from Idaho. And Andrew Corkill from Southern California. We've got Harold Locke. Good evening, stargazers. Gary Albin. Good evening, everybody. And who else is chiming in here today? Adrian Bradley. Adrian was a little bit under the weather, so he didn't come on to the show tonight, but we're glad you're watching, Adrian. He says, good evening. Looking forward to watching the star party this time. My cold recovery went much faster than I expected. Well, there you go. Consider joining in, Adrian, later on if you want. Gary Albin says, hi, James. How are things going? And James says, not bad, Gary. Harold Locke says, Ramones, the melding of real rock. I like the Ramones because it was just fun rock and roll, you know. Mike Wiesner is watching, and Aaron Thompson's watching. Beatrice Hines is watching. She's from across the pond there. And Book Davies is watching. This is a visualization. There's no audio here, but I think it's awesome. Of Stephen's quintet.
That's exactly what it sounds like out there.
Yeah.
Yeah, mesmerizing.
Yeah. Grazing this galaxy. So cool.
One of my favorite things is Stephan's quintet. Might be interesting to note that Stephan is also a comet discoverer. Comet Stephanoterma comes back from time to time. I really enjoyed watching that comet.
James, the astrophotographer, is looking at the moon and Venus with binoculars, waiting for the darkness. Yeah, that was an excellent visualization. I like that. Well, hello, everybody. This is Scott Roberts with Explore Scientific and the Explore Alliance, and it is our 46th Global Star Party, the Meaning of Life edition, okay? In the universe, anyhow. So I guess that would cover everything. We have a great lineup of regular contributors and speakers and a special guest here, Mr. Don Selle from Texas Star Party. He'll be joining us here in a moment to talk about the Texas Star Party. David Levy is, of course, here with us, and he was here with us on Saturday too. And David is the honorary president of the Royal Astronomical Society of Canada, the Montreal Center, and they were the special guest host of the 45th Global Star Party on Saturday, celebrating Astronomy Day. I think that and this was a marathon star party. It went 7.5 hours. So that a lot of real star parties don't go that long. So, where people are up observing and interacting and stuff. But it was a lot of fun, and I'm glad that we did it. David, was incredible as always. I was trying to remember the poem that you had told during that star party, David. Do you recall?
Well, I have it here. It's from the Global Star Party number 45, and I record them all. So let's see where we are. And Saturday, May 15th, Global Star Party 45. And what I quoted was something simple from Abraham Payas, the wonderful comment that he wrote about Einstein. Nature had spoken to him to describe Einstein's joy, having finally shown that he understood gravity, and he realized he's probably the only person in the world at the time who understood gravity. I don't think there are too many more right now who understand gravity. But that was interesting from last Star Party. A little bit different one tonight when it's my turn.
Yeah, it's your turn now.
Oh,
But,
okay.
I did want you to know that Kareem Jaffer is in the audience watching. So, and he was one of the individuals who put together the schedule for that Astronomy Day event. So, want to thank him on the air. Give him a big shout out because he did an awesome job. Him and Russell Freilich. So, thanks again.
Well, yeah, Kareem, I think, did a beautiful job last time, but now it's our 46th Star Party.
Yes, it is.
And I wanted to congratulate Scotty for setting up this wonderful video that we began with showing Stefan's quintet. And when I was looking at it and just wondering the 3D version of the galaxies sort of Stefan's quintet there, and then one extra one that we have, and it was just brilliant. And welcome to our Star Party tonight. And tonight, as we watch Stefan's quintet in the sky, it brings me back to the time when I used to observe it visually with my own telescope. And also the fact that Stefan's quintet opens one of the finest movies that I've ever seen. And that is, what is the name of that film that we all enjoyed so much?
It's a Wonderful Life.
It's a Wonderful Life. And that begins with the scene from Stefan's quintet. But tonight I'm going to quote, as we watch Stefan's quintet, I'm going to quote from Shakespeare, one of his less enjoyed plays, King John. And this quote from Shakespeare has to do with meteors. There are two quotations from meteors. One is from King John, Act 5, Scene 2. This shower blown up by tempest of the soul startles mine eyes and makes me more amazed than I had seen the vaulty top of heaven figured quite o'er with burning meteors. Lift up thy brow, renowned Salisbury, and with a great heart heave away this storm. Meteors come quite often in King John. It's actually one of the most famous meteoric plays. And it reminds me when I was looking the other night through my telescope, an Explore Scientific telescope that I call Eureka. And it's one of my favorite telescopes right now, enjoying it. And I was looking at Comet Palomar last weekend. And it was actually a time when Comet Palomar I thought would be impossible to see because it was so faint at 11th magnitude, except it was visible because the comet was actually a little bit more condensed than usual. So I was able to see it. The other thing about it is that the comet was very close to Messier 3. And I was just able to find Messier 3, move the telescope a little bit to the north and east, and there was the comet. And I close with another quote from Shakespeare's King John. No natural exhalation in the sky, no scope of nature, no distempered day, no common wind, no customed event, but they will pluck away his natural cause and call them meteors, prodigies and signs, abortives, presages, and tongues of heaven, plainly denouncing vengeance upon John, and lovely comets in the sky. So we have lovely comets and Comet Palomar, which we really enjoyed the other night as it sailed past so gently Messier 3. And now back to you, Scotty.
Oh, thank you, David. It feels good every time I hear the Star Party start with David Levy's poetry, and how fortunate we've been to have this all this time, and to have individuals such as they are coming on so often, and someone who's given so much of his time as well as the editor-in-chief of Astronomy Magazine, David Eicher. David, it has been awesome. It's been a wonderful ride through the universe, leading all the way up to the crescendo, the meaning of life in the universe. And so I want to tell you, just friend to friend, that I've been very, very honored to have you on these programs. You've taken the Global Star Parties to another level many times, especially when you had the entire editorial staff of Astronomy Magazine be the special co-host. So it's been awesome. And I want to give you that special thanks. And I will turn it over to you.
Well, thank you, Scott. We'll have to do that with the staff again. They had a lot of fun with that as well. But we had limited ambitions tonight, and that was we thought we would talk about the meaning of life in the universe and get that solved. So nothing drives astronomy like the oldest of all philosophical questions. Are we alone in the universe? Spacecraft missions, of course, for a long time now have focused on Mars because of the possibility of either present or past microbial life on Mars. The crescendo of all the excitement in a sci-fi way over Mars came crashing down 60 years ago with the first spacecraft that went to Mars close up and showed us that Percival was not right. But it's very possible that microbial life could be there in the subsurface aquifers of the planet, and that's something that the current missions are still working toward, finding out about that and drilling down. And of course, the growing cottage industry of discovering exoplanets is a big deal, and what's driving that to a large degree is the feeling that there could be other Earth-like planets. We still have not found another Earth, contrary to dozens of exaggerated press releases over the last 15 years. But we're getting to find smaller rocky worlds out in the nearby us in the galaxy now, particularly with TESS that's in orbit now, of course. But still, we only know of one example of life in the universe, and that's right here on Earth, of course. And so the conservatives with regard to life still can point to the fact that life may be exceedingly rare or maybe even unique on our planet. And they point often to the Fermi paradox. It was posed by Enrico Fermi. If the universe contains life, where is it? Why hasn't it shown up on our doorstep? And that's a legitimate question. But let's think about what the universe is just for a moment. The universe contains at least 100 billion galaxies, cosmic inflation aside. Cosmic inflation, if true, which probably it is, the evidence leans toward, but that would mean that the visible universe is not nearly the entire universe. But let's set that aside and say that we have conservatively 100 billion galaxies. We also have evidence that planetary systems are common around us in the galaxy, in the star systems that we've looked at carefully thus far. And consider the number of stars in the Milky Way galaxy. That's something on the order of 400 billion stars. We don't know exactly, of course, because red dwarfs are faint, the most numerous stars, but it's several hundred billion stars we have in our galaxy. Astronomers believe that most stars, from what we've seen, maybe about 70 to 80% of stars, very conservatively, have planetary systems. Maybe all stars do. If you look at the dynamical models of how stars form, it's not surprising. You have a circumstellar disk. So again, to play it very conservatively, let's say that we have about 100 billion stars per galaxy. So that works out to about 10,000 billion stars in the universe, and roughly 10 to the 22nd power planetary systems, or 8,000 billion planetary systems. That's discounting inflation, and that's being conservative on the estimates of the numbers. So, question for our esteemed panelists here. Do we really believe that, although we don't have the evidence yet, do we believe that we're the only planet in the universe with life?
No.
No way.
I would agree with you.
Nope.
I would agree with you. The odds would seem to be staggering. But of course, to say that we're in our infancy of being able to detect anything about other worlds is an understatement, of course.
Yeah.
Let's consider for 1 second what life is. Life exhibits 6 fundamental properties. It's ordered, as in the ordered arrangement of atoms in its molecules. It exhibits reproduction, life does. It exhibits growth and development, living organisms. It shows utilization of energy from the environment. It shows responses to the environment around it. And it also shows evolutionary adaptation to Darwinism as well. And this is something that's become clear in more recent times here. If you talk to people like Richard Dawkins and others who are leading evolutionary biologists, that it appears that life, it's a fundamental property of the organic chemistry of life, that Darwinian evolution is baked into the way chemical reactions take place. So here's another question, though, to consider. Would we recognize alien life if we saw it? We're contaminated and spoiled and, treasure the sci-fi stories we have from Hollywood, which are amazing because almost always we have bipedal organisms with a pair of human-like eyes. It's just the damnedest thing. It almost always happens. And I'm really impressed, I have to say, mostly with shows that I loved in my youth, like the original Star Trek, because to me, it seems that most aliens speak English, which surprised me too. But in reality, life in the universe could be radically, dramatically, almost unrecognizably different to what we are used to with our path of our Darwinian evolution.
Mm-hmm. Right.
From the last sorry, Scott, please go ahead.
You're just making me think of that. Very much. And, but I'll get on. I'll ask my questions towards the end here. It's some questions.
Please jump in if you'd like to.
No, it's okay. I don't want to interrupt. Go ahead.
Okay.
David, just one thing I wanted to say is,
sure.
did you already bring up the Fermi paradox?
Yes.
Yes. So you're outlining all of that, right?
At the start, yeah.
Excellent.
If life exists in the universe, where is it? Why hasn't it shown up on our doorstep? And there's an answer to that, in part at least. But
I'll chime in a little later. Yeah.
David, if I could say something at this point, it's actually one of the late Carl Sagan's most exciting interests. And I knew Carl very well, actually, and we got to spend a lot of time during Shoemaker-Levy 9's Impact Week. He had a lot of criticism of me, but he really adored my mom, who was there at the time, because my mom was a geneticist, and that was one of Carl's major interests, genetics. And I was really enjoyed. And I remember talking with Mom afterwards. I said, well, Carl had he might have loved you, but he really had a lot of criticism of me. And all my mom would say was, yeah, well, Carl was kind of cute. And I really enjoyed him. Back to you, David.
Well, and Carl was a huge influence getting me involved in all of this as well, as you know, David. And as you can talk to Annie about now, Carl was one of the original, we're talking about the chemistry, biochemistry, and organic chemistry. Carl was one of the first people to study astronomy aggressively and build his undergraduate background in chemistry into it in a field in what came to be called cosmochemistry, which was thought to be kind of a radical departure at the time when Carl was in grad school. So he kind of bucked the trend and was in really at the ground floor of all of this thinking of merging astronomy and chemistry together. So very important for you to have brought up Carl, David.
Thank you.
Yeah. Okay. Well, From the last generation of scientific evidence, looking at life on Earth, and I'm talking about microbes essentially, because sophisticated life is fragile, but microbes we've seen with research everywhere we've looked, in very hot, very cold, very deep environments. It's much hardier and more tenacious than anyone ever would have imagined a generation ago, life on Earth. Spectroscopy also tells us that chemistry is uniform throughout the cosmos. We know that chemistry works the same way throughout the universe. Temperatures, pressures, many other local factors in the universe would vary wildly, but the elements and the way chemicals combine electrochemically are uniform throughout the universe. So that's a very encouraging thing about how we understand how the universe works. We also know that the building blocks of organic chemistry exist throughout the cosmos, and that they're common, for example, in the solar system. The first sample return mission, for example, from a comet, that was the Stardust mission that sampled comet Wild 2 and returned the sample in 2006. Found glycine in that comet, which is the simplest amino acid of all the amino acids. And of course, there are many other examples of cometary and meteoritic evidence of complex organics in meteorites that have fallen to Earth as well. So it seems highly likely, numerically, that life is common throughout the cosmos. And even intelligent life, civilizations, I would argue. But here's the big pause. The distance scale of the universe is incredibly, almost unimaginably vast, even to the nearest stars. And we've talked about this before, but let me just quickly say, if I'm not going too long, Scott, imagine one astronomical unit as being 1 centimeter, the distance between Earth and sun. We've traveled physically as human beings an almost imperceptibly small fraction of that 1 centimeter.
Right.
The physical edge of our solar system, the inner edge of the Oort cloud on that scale, is 10 Lambeau fields to your right.
Wow.
And the nearest star, Proxima Centauri, is more than 4 times that distant, that greater distance than that. So the distance scale of the universe, this is something even people who are really active astronomy enthusiasts don't really take to heart or want to remember or think about or care about. The distances between astronomical objects, even the nearest stars, are almost unfathomably large.
Right.
So it may be, as Carl, we come right back, David, now to Carl. It may be, as our old pal Carl Sagan was fond of saying here, that life exists richly throughout the cosmos, but it's so distant that we'll never know about it. And that would break the hearts of course, SETI researchers. We may know about it, through unambiguous signals, but it's extraordinarily unlikely if you look at the energy it would take and the time to travel physically very far. It would take significant fractions of the energy in the galaxy to travel to the nearest star. So having alien beings who would have 2 eyes and walk around and shake our hands, land in Central Park and take us to dinner at Tavern on the Green probably is not going to happen. Okay. Just to cut to the chase, even though we've all been weaned on, enormous amounts of sci-fi in our lives. But we do have the most amazing gift that we can imagine in the universe, I would argue. And that, I would argue, is the meaning of life. Because as we've talked about before on this program, we're made of star stuff, as Carl used to say. The atoms, literally the 8 octillion atoms in our bodies, roughly, on average, each of us, were literally made in Big Bang nucleosynthesis, the 2 lightest elements in the early history of the universe, and mostly the heavier elements in exploding stars or colliding neutron stars. So for us to be made out of atoms that were created in stars or in the early history of the universe. And to be sentient and be able to think about this and look out into the universe that made us, the matter. And granted, a big thanks to your parents as well, but we're made out of the stuff that came from that universe, the universal expansion and stars, massive stars. To be sentient, to share this, to talk with each other, to consider it, to look out at galaxies and fly through Stefan's quintet and see that NGC 7320 is in the foreground and the rest of them are a cluster, and talk about that and what it means to us. That's incredible. To me, that's what the meaning of life is, that we're here in an almost miraculous combination of atoms, and we can share that as friends and think about it and share our love of the sky and of the stars and our knowledge of the universe. So that's, to me, the ultimate meaning of life. And if you don't like that, then I'll just have to offer Michael Palin's definition of the meaning of life to conclude. Well, it's nothing very special. Try to be nice to people, avoid eating fat, read a good book every now and then, get some walking in, and live together in peace and harmony with people of all creeds and nations.
Pretty nice.
Thank you very much.
Pretty good.
So now we can debate and question and raise anything you like and so on. But my feeling is that there's a whole lot of life out there, but it's so vast and so spread out. And of course, microbial life or simple life would be fantastically more common than civilizations would be. But there's nothing unique at all from what we've seen about Earth and the whole history of astronomical discovery coming out of what was astrology a millennium ago. That's one big lesson that we have every year since then in the last millennium. There's nothing really special about Earth, despite all our, early pretensions. So I would think there's a lot of life out there, but it is a long, long, long way away, and we may never really know it.
Yeah, and I guess on the flip side, maybe no one has detected us either, as far as if the distances are so great. But
it's very, you can talk to Seth Shostak and Jill Tarter at SETI and others who we're friends with and are involved in STARMIS and so. And you think, well, energy, moves across the universe. Why wouldn't you detect all the life that's out there? But to have the right kind of signal, it has to be pointed at you at exactly the right time and in the right way, and you have to be listening in an unambiguous way. And energy does get lost over very long distances. Mm-hmm. You can't point a flashlight on Earth and still see those photons in the Andromeda galaxy. It does not happen. So it's an exceptionally difficult thing to detect unambiguous, intelligent life, even if there's a fair amount of it out there.
Mm-hmm.
Yeah.
Go ahead.
I'd like to mention something a little bit off on the other side of this question.
Sure.
That Leif Robinson said once in a lecture he gave that I've never forgotten. And it also comes from a Star Trek episode called Balance of Terror.
Ah, yes.
DeForest Kelley, as Dr. McCoy said, something that I thought was very important. He said that you talk about the number of stars in our galaxy and the number of galaxies in the universe and the number of clusters of galaxies could be more than all the sands of all the sands in all the beaches of the world, all the grains of sand. But of all that, and perhaps more, only one of each of us. The actual uniqueness of each of us is really makes us precious. And I think Leif said in a speech that I've never forgotten, that we are incredibly unique. And so that's a little bit of an opposite way of looking at life in the universe.
And that's absolutely true, yes. David. Of course, there is no parallel Earth world or parallel universe that has another David Levy or thank goodness for everyone else, another David Eicher. You know, we are absolutely unique and individual, and there's no question about that. So that, again, you know, a lot of people, when they first get into this hobby, you know, are overwhelmed by this feeling of looking out at all these things in a telescope, and my God, this crashing realization of I'm so tiny in the universe and unimportant. But that point is exactly true, David. It's the counterpoint. There's nothing else in the universe like you, and so you couldn't be more important to the universe.
You bring up a really good point when doing outreach, David. That's often the first thing that we hear as people look in the telescope. We are so small, and it also reminds me Carl Sagan's famous pale blue dot image, where he decided to have the Voyager turn around and take the shot. And we're a species that's able to know just how small we are. If you go far enough away, you know, from the planet, you say, you know, everything that we're going through, including the very reason we're doing this remotely because of being safe of a disease that's on our planet. And yet it's all contained in something that, you know, you can barely see a few million miles away. One thing about us too, that you talk about meaning of life to share. We've done that with the Voyager probes to where they'll outlast us all, and who knows, we're taking the chance that they'll still be able to be their own citizens around the galaxy, that they could be picked up millions and millions of years in the future, even though that we're not here. So we're willing, even though our lifespan doesn't travel but maybe 100 years or less, we're still paying it forward to future generations. And you talk meaning of life, you have to think that. And, you know, me, myself, having a religious side, it's nothing. I tend to look at the science itself. There's, of course, it's all about God, and then there's the science side. You know, there's, just look at it for yourself. Do the discovery for yourself. Look in the telescope.
We're all human beings, Adrian. Yeah,
we're all human beings.
Exactly.
And traveling on this planet together.
Yes. And that last thing you said, Dave, just be kind, stay away from fat. There were like 3 or 4 of the things that I was able to say that I successfully did. And I'm working on the 4th somewhere down there. But you know, that's actually a very simple summation of it. Where we came from, we know that it's formed in stars. There's a lot that we can discover, and there's nothing wrong with using our lives to do that. There's also nothing wrong with being kind to one another. So there are a lot of lessons you learn just by looking at the stars.
We're all, you know, a lot of people think about the differences that people have. Well, they're so incredibly minute compared to the absolute commons that we all have together. It's ridiculous. So we do all need to celebrate our lives together. And it's funny, Adrian, you mentioned that, you know, this feeling of, you know, the pale blue dot and how tiny our world is looking back from Voyager. But, you know, it's another thing, talk every to a last man, every Apollo astronaut you ever talk to, every single one of them says, you know, I held up my thumb, you know, and blocked out Earth with a thumb, you know, and just that shivering, shaking, you know, feeling of how tiny and how fragile this world. We need to take care of this planet as well as each other. Yeah, it's the only one we have.
Yeah. Yep. It's our life support system.
Yep.
I think so. And Adrian, you brought up an important thing, and Carl's talking, and then in that final book, Pale Blue Dot, he talks about it. He had, I think, a whole chapter in there, billions and billions. Of course, he never said in his working life billions and billions. It was Johnny Carson that kept on talking about the billions and billions. And then in his final book, he said, I'm going to say it right now. Okay, billions and billions. And he really did enjoy saying that the preciousness of life, and the fact that you look at this pale blue dot, what it means, the fact that everything, you look at that little image, that little blue dot on Voyager's picture, every war that's been fought, every play that Shakespeare wrote, every beautiful thing that you can think of, and every ugly thing that you can think of, that took place on this planet, all of that, everything that we know took place on that little single pixel of light that Voyager took in that one picture. I think that's a very powerful image. And thanks for bringing that up, Adrian. And thanks, David, for your wonderful talk.
Yeah, very profound.
There's some chat here, some comments from our audience. And Ollie from Ollie's Astro says down in Australia, he says, I enjoyed a talk that Brian Cox gave here in Melbourne, where he said meaning is a property of human beings. Aaron Thompson mentions, he says, we do not come into the world, we come out of it as leaves from a tree, as the ocean waves, the universe, people. And Aaron Thompson goes on to say, every individual is an expression of the whole realm of nature, a unique action of the total universe. There's a quote from Alan Watts. Yeah, I mean, this conversation really makes us take a hard look at what we think is of life and our place in the universe, and it's something that that I often think about. I will pause to think about what all this stuff that's going on in front of me, you know, whether it's I'm involved in business, or I'm talking to a friend on the phone, or we're doing a global star party, or whatever it is, you know, I keep in the back of my mind that we are on this little planet hurtling through space, going through fields and realms of energy, and that there's this whole constant birth and death cycle of the stars and maybe other galaxies, maybe other universes, who knows, you know?
I remember when I was a kid.
Every possibility that we could possibly imagine, okay?
Yeah.
Probably happening somewhere out there.
I remember when I was a kid, I remember realizing, I don't know if I was 6 or 8 years old or something, but I had this strange feeling all of a sudden when I thought about, why am I here? What is this?
Yeah.
Basically, what is this? And that was the first time I'd ever thought about, you know, this is really strange when you think about it. How do I know? How do I, you know, it's basically, what is this? You know, that's basically my question. That was my first realization that something was different or something weird or something, you know, didn't make sense.
Yeah, if I could have the floor for just one more moment. An interesting phone call last night. I was sitting here in this room enjoying a late night episode of Star Trek from the original series I was watching, when the phone rang at 1 o'clock in the morning. And I picked up the phone, and of course, when that happens, it's sort of, you know, you don't get a good phone call at 1 o'clock in the morning. But the person at the other end of the line was almost unintelligible. He was trying to say something, and I just couldn't understand him. And I told him, I said, that I'm going to hang up right now. But the phone rang a second time, and I picked it up, and I said, who are you? And he said he was a member of the police department in Long Island. And he said he was calling to speak with my wife, Wendy, about her brother, Sandy. And it was something that turned out that it took us a while to get into the conversation. And we actually had to call that precinct to find out that it turned out that they were simply doing their job, and they were trying to find Wendy's brother, Sandy, who had actually left the home that he was staying at, and it was turned out to be a very interesting thing. It turned out that the police department was able to locate Sandy eventually to bring him back to where he was supposed to be. And I was thinking how interesting that was, that that this police department was actually trying to do their job, trying to bring a member of our family back to where he belonged, and that they succeeded in doing that finally. It was actually a very wonderful conversation that we had with this police department. We called the police department, a lady answered the phone and right away said, okay, look, you really are talking to the police department in Long Island, and we're just trying to get Sandy back to where he belongs. It was really a very interesting, wonderful conversation. And I think on that note, I will give it back to you, David, and back to you, Scotty.
I'm glad that it resolved okay, David. That sounded
Yes.
worrisome for a moment there. Yeah.
Yeah, I was like, it sounds like a scam at 1 a.m, but it turned out to be a real event and you were glad that you were there. There's surprises happen all the time. And sometimes they turn out to be really good ones. And that's part of it. There's a tie-in to, life in there somewhere, and seeing you're out there looking at the stars, and then you see something that no one else will see, something bright, some bright meteor, something, and almost like it was meant for you to see it and no one else, just like that call was meant for you, David, and you answered it. You were there at the right time to see it, and things like that can really sit in your heart after you've seen those. It's like, wow, that's some of all the things that go on in our universe. This thing was unique, and it happened just to me. I've had a couple of meteors I've called out and said, okay, I'd really love a meteor to go through this shot right now. And then I look away and I look at my phone and I look in my camera and there's a meteor going right through my shot. So those things happen.
Do happen. And Adrian, looking at you and surrounded by your panorama of the Milky Way, your beautiful, magnificent photograph behind you, it's thrilling to be able to know. You never really know what is going to happen in life. You get a phone call or a Zoom session or something that totally is unexpected, or listening to David's wonderful presentation about if life has any meaning at all, that we're just able to enjoy it and see it. We never know if this will happen, and we never know if the presentation of life will actually bring us something that we will never forget tonight.
If I could just bring a couple of words in to get us back to the origin of life as well. I mean, life is originated. It was a natural process. Well, nature's kind of messy, and things don't always go in a deterministic way. And no matter what level you look at it from, all the way up to where we are, intelligent life, it's kind of a messy world out there. And but the good news is that even though things sometimes seem to happen randomly, we do get these very good outcomes. And I think that has to do with the fact that we're intelligent beings, that we have emotions, that we can bond with each other, we care about each other, and that kind of transcends just the messiness of nature. Even though it doesn't work all the time, I think that's why we get these good outcomes.
Right, Don, and life itself is a very positive force. I mean, just the fact that it exists and it thrives and continues to strive, and we're obviously striving for the stars as well here, both mentally and also physically, trying to expand our reach and our understanding through the universe. And actually, if I could, I'd like to share my screen briefly. So David, on
Sure. Yeah.
let me just share my screen for a second here. So on the topic of Fermi paradox, I highly recommend. I sent a link in the chat. So maybe Scott, if you can send that to the bot, to the streams. This is an excellent. I highly recommend. If you want to really dig into what David went through regarding all the different possibilities of explaining why we haven't discovered life yet. The Fermi paradox Wikipedia page has a beautiful breakdown of all the. Makes a very good read. And if I could just highlight the context, sort of the different types of scenarios. So, for example, these are the hypothetical explanations for the paradox. If I go through, the first is rarity of intelligent life. Is it rare or non-existent? Is there a periodic extinction event by natural events, like supernova or whatever? Evolutionary explanations. Is it that intelligent alien species haven't developed advanced technologies yet? Or is it in the nature of intelligent life to destroy itself? Or is it in the nature of intelligent life to destroy others? Civilizations are only broadcast detectable signals for a brief period of time. They go quiet after they get to a certain level of advancement. Alien life might be actually too alien, as David talked about. It might be completely different than we've always, the bipedal hominoids that we always put in our sci-fi. Sociological explanation. Colonization is not a cosmic norm. Everyone stays on their home planet. Alien species may have only settled on part of the galaxy. Alien species may not live on planets. They may live in nebulae or other gaseous form. Alien species may isolate themselves from the outside world. They might be xenophobic. Economic explanations, lack of resources needed to physically spread throughout the universe. I mean, the planet Earth, of course, is only so many resources. We are consuming them. Perhaps to get to the next level, there is a limit on those types of metals and materials to be able to get to the next stage. Is it cheaper to transfer information than explore physically? This is the part where even if we detect life, and we're able to listen and detect it with radio technology or whichever, we couldn't communicate because of the distances. There was not a reciprocal capability. Discovery of extraterrestrial life is too difficult. We haven't listened properly. We haven't tuned to the right modulation. We haven't listened long enough. We've only briefly, electricity has been around we've only discovered and harnessed it for the last couple hundred years. So intelligent life may be too far away. Just like the flashlight thing, it just dissipates. You cannot detect the signal strong enough,
or the modulation of the signal.
Or the modulation of the signal.
But if there's
yes,
just a tiny part of a fraction of a signal, and it's separated by 1,000 years, and then comes the next one,
Yes, exactly. Yeah.
The WOW signal that you can see on Wikipedia as well. That could have been like part of that or something, So
yes,
we tend to think of, as we always do, that everything's like us and that we're kind of the center of everything.
Well, that's the other thing is, trees. Who's to say that trees cannot become intelligent after, a billion years?
yes.
And their time frames, their time spans are such, they live 1,000 years or 10,000 years, maybe. I don't know.
And it depends on what you mean by intelligence too.
Exactly.
But I would offer a caution, if I could, at this point, that Wikipedia may not be an academically authoritative source, first of all, on things.
Absolutely.
And there's a lot of stuff here that's that's purely speculative rather than based on any knowledge or research.
Yes.
Absolutely. Absolutely. The point is that it
sorts of
brings
things
up,
are possibilities, but the
it's-
evidence is leaning in the other direction now. Biochemists would say about the commonality of life in the universe.
Yes.
Maybe not intelligent. We don't know. We can't quantify how many civilizations we're throwing darts at and guessing are out there, but it's much easier to get life going, we now know, than anyone imagined. And again, Richard Dawkins, who outranks Wikipedia with all due respect, and others argue that Darwinian evolution, in other words, the path of simple biochemistry, we don't know how things go from proteins and amino acids to RNA and DNA yet, but there's a lot of research going on to bridge that gap now. But once you have self-replicating molecules, a lot of biochemists now will actually argue that it's an inevitability that things will gain complexity over time.
Yes. No.
That
Yeah, I
you
think
can have, the entire life of an inhabited planet with, for us, it took more than 2 billion years to go from microbes to things that were more sophisticated because of the great oxygenation event, when there was a lot of free oxygen suddenly available in the atmosphere 2.6 billion years ago. That's what made more sophisticated life more possible on Earth.
I think that's another way to characterize life. If it brings order to chaos in general,
Yeah.
right?
Yeah. And it does, and it's extremely ordered, except that the second law of thermodynamics has the last laugh in the end for all of us.
Yes, of course, entropy. So life decreases entropy, I guess you could say.
We're extremely efficient until we can't overcome the second law anymore. Yeah, and we break
locally,
down.
only locally.
Right.
no, I appreciate that, and I just wanted.
While a lot of these things are certainly important considerations, there's no evidence that the nature of intelligent life is to destroy itself, for example. No scientific evidence necessarily. So these are all possible concerns that could be posed to suggest that life is rare relatively, that intelligent life is rare. And it
That's
may
the right context, yes.
And
yes.
it may be, this may all be true, but all I'm saying is that the trend over the last generation is leaning the other way, that it's a lot easier to get life going and to complex it up. In fact, Dawkins has a phrase in his writings, Darwinism doesn't need to be magicked into existence. It's purely the outcome of, and we say that, life is random and there's chaos and everything. That's true. And in our lives especially, but atoms don't combine randomly. They combine because they're electrochemically attracted to other kinds of atoms in an ordered way, which is why we have diamonds, for example, and all sorts of other things. They combine in crystal lattices in an organized, similar way all the time. So that again leads to
deterministic universe.
Arguments that would suggest that maybe complex organic molecules are more common, much more common than people would have said 40 years ago, when the Fermi paradox was very much more in fashion. That's all I'm saying.
I want to, just let me reframe this. I totally agree with you, David, but I just wanted to say that what my point is, and what I think is interesting about all this is, I believe, to your point, I mean, there is the scientific, thing. This is just the categorization of different possibilities.
Sure.
And then, like you say, what I believe, just looking at all this, it's a thought-provoking exercise to look at all of them, and then think, because it's very likely, I think, just because of the vastness of the universe, that actually all of these are correct. All of them are correct, and it's just a matter of time before we discover, the distribution of which are the more likely ones. Because we're going through a journey where, just like any scientific process, you come through a number of theories. These are all the possible theories. of why we haven't explained, but only time will reveal the distribution of which of these are actually factual, right?
Absolutely. Absolutely. Yep.
Yeah.
I think one thing we can agree on is that our global star party tonight has touched on something very, very important, talking about the meaning of life and the different ideas about existence and why we are here. It's been you've really touched on something really rather quite central and quite important.
Yes.
Well,
Yes.
it's sort of the ultimate question. And thankfully, we've learned that, reading a good book and, avoiding fatty foods and getting some walking in are really the ultimate answer.
Less sugar. Yeah.
Now we can sleep soundly tonight.
Yes,
Yeah.
that's right. That's right. Well, David, thank you so much. I mean,
Thank you, David.
this is something that we're going to be thinking about for years, I think. And we'll remember this global star party for many years, I think. I would like to bring up Libby and the stars next. Libby has been with many of our global star parties. She is an avid amateur astronomer. She is absolutely convinced that one day she'll be able to take that trip into space as other astronauts have. And I believe in her conviction and her focus and and her bravery in coming forth amongst so many venerable speakers and people that we have had on these programs, to have an 11-year-old step up and give her take on the universe, global star party after global star party. So I'm really happy and proud that she's done that. And Libby, last time you talked about Charles Mercier, and you also talked a bit about what it's like to be a young student, enthusiastic about astronomy. What's it going to be about tonight?
Tonight, I decided to talk about Jupiter's red spot. So I have another presentation to share.
Okay.
So I'm going to share that, and I've gotten good at these because I do these for school too. So tonight I'm talking about Jupiter's red spot, and I kind of thought it was funny whenever so this is Jupiter's red storm, basically, as you can see in the picture. It's off to the bottom left. And I thought this is kind of funny because I'm actually getting some thunderstorms coming soon tonight. So of course I'm talking about thunderstorms when there's a thunderstorm. So what is Jupiter's red spot? So it is a huge storm that's been going on for a couple hundred years on Jupiter. And whenever I look through a telescope, you're able to see it. It's in a lot of the pictures. It's like a huge dark reddish, and it's a very, very powerful storm. And one time I asked my friend, and I decided to make it a trick question. I said, what is the strongest storm in our universe? And she said, well, the Joplin tornado. And I said, no, it's the big red storm. I mean, I wouldn't say in our universe, there's probably even bigger ones, but it is a pretty big storm in our solar system. And it's humongous. Jupiter's huge compared to what Earth is. So there's going a full, maybe like a quarter of Earth can fit in Jupiter's red spot. That's because Jupiter's ginormous compared to Earth. That's how big it is and insane. So this storm is so powerful that it is almost 2 times more windier than a Category 5 hurricane. So we get a lot of hurricanes here on Earth. And then we get them, it's hurricane season almost every year. We get some pretty nasty hurricanes. And the winds go up to 268 miles per hour. And so usually when you see a hurricane on Earth or a tornado, they usually go up to 100 and then at the most at least 150, and this is going up almost to 300, which is pretty chaotic. But nobody lives on Jupiter like humans, so they isn't really there to experience it. So this storm is very, very, very powerful. It's been going on for over 300 years. So it is definitely a noticeable storm by looking through a telescope. So what we see from space. So when you look at Jupiter through a telescope, every single time I've looked at it through a telescope, you cannot see the clouds moving, but very much so they are moving. And all of Jupiter's surface is just a bunch of moving clouds around. There's a lot of storms, but the big red dot is the most famous of them all because it's the biggest storm on Jupiter. And so the little picture over there is Voyager 1 going to Jupiter, and you can see its clouds moving and how fast it is moving. And you can just see there's little dot storms just moving across the surface. And so when we're looking from our telescope, it's just still, so we can't see it moving when we're looking through our telescope. I wanted to talk a little bit about Earth storms too and how they relate with each other, because when astronauts go to space, I learned a lot about this when I was in space camp last year. I get a chance to go back to space camp this year again. But when I was at space camp last year, they were teaching us about satellite images. So basically, a lot of the times when they're in space and they can see a hurricane from the International Space Station mostly. Sometimes we'll go on NASA and they'll say like, oh, we can see the eye of the hurricane and we can see where it's moving. And back when I was at space camp, we had we all did a little group project where they showed us pictures of different natural disasters all the way from space, and we had to determine what they were just by the images. So it could be volcano storms, you could see that, and definitely hurricanes, you can see that. You can see the eye of the hurricane and it moving over. You can see storms, you can see just regular clouds too. So Earth storms are almost a little bit by Jupiter. There's just a lot less storms on Earth than there is on Jupiter, and the storms are a little bit less violent here. And I know we definitely don't have almost 300 miles per hour wind blowing storms, maybe at 150 at the most. So I wanted to talk a little bit about that. So thank you guys for having me on today. It was very fun. And it's kind of iconic, the time that I'm going to talk about storms and weather, that it's storming outside. I've always loved storms. I've never been afraid of them. I mean, unless I had to take shelter, but I've always loved storms. And I kind of see that as a cool thing, that I connect my love for storms and my love for astronomy together. And you can see there's different weather on all different planets. And imagine being an astronaut going to Jupiter and then just being blown away by the almost 300 mile per hour winds. I mean, that's just so crazy to think that it's been going on for so long right now, and it's still going on the second I'm talking about it right now. And it's just so crazy because there's more storms on Jupiter too. And I've always loved all the stormy weather here. I'm like, oh Lord, I'm like, sometimes I'll get in the car, and if it's safe outside, then I'll storm chase in my mom's car with her. And I like to sit outside and watch the rain, and I definitely enjoy the rain a lot. So it's kind of crazy to think that the big red storm, that's like a crazy storm that's still going on right now in our solar system, this second that we were talking about it and having this amazing discussion about it, it's out there in Jupiter right now, and it's still there. to this day, almost 300 years too, and it's still going on. It's such a powerful storm, and I think weather is something that it is definitely something that is very important when you're sending astronauts to a different planet, because you can't send them to Venus or else everything will melt, and you can't send them to Jupiter or else they'll be blown away by this wind. So I definitely think weather is something cool on different planets to research and study about.
Absolutely. Absolutely. Thank you very much, Libby. That's awesome. That's
Thank
awesome.
you for having me on.
Yep. And thank you. Thanks for being on again. And we'll see you next time. Okay. So up from Stockholm, Sweden is Pekka Hautala. And Pekka has not only been in the audience of our daily shows many times, he's been featured on some of our programs, and including the Global Star Party. And he has been recently a huge champion for dark skies. And so Pekka, what's happening in Sweden these days?
In Stockholm, I'm just waiting for the sunrise. Yes. Okay. From the IDA side, International Dark Sky Association side, I am waiting to speak the first little bit longer conversation with the politician here, but right now they are in the middle of the budget for next year, for the whole big budget. So she's very busy, but she has promised me, he's so enthusiastic to talk with me from point of view from our side. So she will contact me after when she gets some time. So it's going on. I got my lamps shielded and turn it off and so on. So I draw down the Porter scale, maybe one scale, maybe two even. So I have very good opportunities for next season to get some DSOs for real.
For real, yeah. For
real, yes. And back to these topics today about why the life and what is life and so on. My journey in that question began when I was very, very young. And I can say, Libby, I can see myself in you when I was in your age. I was just hoovering the information where it was available that time. Today, you have Google, you have Wikipedia, you have everything. But that day when I was starting, we have a very, very small and limited library. 2-3 books about astronomy. And I borrowed them. And the period to borrow was 3 weeks, I think. And I went back and asked them if there is somebody who has asked them or are queuing for them. No. Okay, I will take them again for 3 weeks. So I was making handwriting copies from those books and so on, and writing down the most important that I have to remember and study again. So I was writing by hand from those books. And I did 3-4 times. So I repeated a long time. So the information for us who were living in smaller villages in Finland was not so big as it's today. So you have computers everywhere. In your phone, you can study to be an astronomer almost. But okay, then I began to think about universe, about in Libby's age for real. What is the universe? And when I read a little bit later about the expanding universe, and okay, then I thought, okay, stop, hold your horses. So in what it is expanding? If universe is everything and it is expanding, it must expand to something. So there is a boundary, there is a grid between the nothing and universe, because it's expanding to something. And what is that something? And I haven't figured it out, but when I study today, you have to look that universe is everything. It doesn't have boundaries. It's so long and so long. Okay, we met universe somehow, but what is after when universe stops? There must be something, because something cannot expand if there is nothing to expand to. David are looking me at, okay, I will shoot you. I will take you down, guy. You will. I know that you will. And then I thought, okay, take a subtle bulb. How do you say, from soap bubble. It has a sphere inside, and it has a thin sphere, and it's hovering in, let's say, nothing. And we take off that small thin layer, then you have something in nothing. I don't know if I'm correct, but I saw a Finnish interview in Finnish YouTube channel. It's still there. There was 3 guys. There was stationary in somewhere in Finnish wooden forest, and they have the dinner. It was one cosmologist and theologist. He was studying both, and one astronomer and one priest. And they was talking about the universe, alien life, and how long and his our knowledge, how long can we expand our knowledge about the universe and everything. And the astronomers told that the human brain is not so advanced that even if we know what's happening, we cannot process that amount of data. So our brain is not made for those huge data that reveals to us that our brain will say stop. Now it's enough. And what the fun was, this is nothing against any religion or something, but the astronomer asked for the theologist, who is also cosmologist, that in Bible says like this, and astronomer says like this. And he told that it has been proven several times in history that Bible has adapted astronomers' events afterwards and telling, we told you so in Bible that this will happen. And they had a very, how could you say, very, very good conversation and dinner. But the conclusion was, how long can we continue to understand universe? And the astronomer and cosmologists, they told that that's only our brains, how long we can understand the data we get, because there is a lot of data. Maybe we can't, because now we have dark matter, we have dark energy, we have black holes. I saw a couple of days ago an program, and there was a Swedish astronomer, and he was studying black holes. And they have found now that in the middle of the galaxies, where there has been a black hole, there is burst. The warm burst that comes out is known for a couple of years now. And there is a gas around these particles that comes out. So the hot gas helps to make this burst. But on the other side, they found a cold burst. So they are studying with huge telescopes. I don't remember the telescopes. Edna, I think. Could it be like not something like that? David, do you know the?
I don't know on the name, and of course there's central supermassive black holes now thought to exist in almost all galaxies except for dwarfs.
Yeah.
So they're very common, and of course the material that is not falling into the event horizon is often being hyper accelerated and shot out, and that's how we detect the energy from them, whether it be a quasar in the early universe or a more well-behaved black hole later on.
And she was so interesting because they found this cold burst. And that was something they
cold in what sense?
It had not gas, hot gas around in the burst, because the particles is inside and it's surrounding by a hot gas, and that's what they saw. And they have discovered that the small particles, what they are reading now with radio telescopes, that they are high frequency waves that goes into this particle. I don't remember the name of the particle, but when it's go inside the particle, that particle will transform the wavelength to longer waves that they can read. So that was very interesting program. And I will follow up what she will make some discoveries. But the life, there is a saying, I was just looking if this is the international. We think here in Earth that, and that we say in Earth that when in Rome, do as the Romans do. And why don't we think that on exoplanets, the same rules is applied? We are saying that life is when red dot is there and blue dot is there, and they are so far away and they are in this environment. That is life. But over there, they are not following our rules. So maybe they are swimming in lead or something, in melted lead.
Well, and as far as we know, the whole history of science, physics is physics. It's universe, chemistry is chemistry. We know that spectroscopically. Except what you say now, what life, the range of life could be unbelievably vast and could exist not only in completely different environments, you say swimming in lead, but also based on different kinds of chemistries. It's often, carbon is an extremely sexy, attractive element for life to be based on because it combines so easily, and you know what I mean? But as has been written about many, many times, there, silicon-based life. There could be living beings even that are sophisticated with very, very different properties to adapt in what would be extremely hostile worlds to us we'd never be able to live in.
Yeah.
So I mean that supports what you were saying, I think. Yeah.
And there is, I wrote about this, read about this a couple of years ago, about alien lives, if they exist here or somewhere else, that our eyes are working on one wavelength, and they body, if they don't have body, can shake in one wavelength, and we don't see them.
Imagine sophisticated living beings that see microwaves.
Yeah.
And not the visible spectrum. It would almost be absurd statistically in terms of evolution for lots of other sophisticated beings to also see this narrow slice of visible light.
Yeah.
So that exactly, yeah.
So we are, if I say I came to you and say, I have this box. The first thing human being asks, how big? So we have to have measures so we understand what are we talking about. If we just say, I am coming with big thing and no questions, that would be odd. And out there, maybe they don't have measurements. I don't know. But we have to we have to look outside the box before we get crazy.
we see things in our own context, which
Yes.
we have to try to take ourselves out of. Yeah.
Yeah, we have to if we want to understand the big picture of everything.
Yep.
Yes.
It's like you know, in the depths of the ocean by volcanic vents, right? That environment is completely hostile to normal life as we know it. Yet they're discovering as a whole ecosystem that, to David's point, a certain environment might make a certain element more likely, more sexy to combine. So carbon in the normal universe, steady state of temperature and all that, carbon tends to be very likely to combine. However, there might be locales like the vents where other elements are more likely to combine just as well as carbon does in a normal environment.
Exactly.
So this is to your point, Pekka, as well with the lead concept, right? If you're around a star that's supermassive or something, maybe the chemical properties change, and all of a sudden life as we know it has a totally different likelihood of forming in a different form.
And we don't know, but you know, hydrothermal vents would be very dangerous and would kill us if we were exposed to them now. We're fragile, awfully fragile human beings, among the most fragile things we know of. But you know, we don't know, of course, but they're the likeliest candidate for the origin of life.
Yeah.
So that, you know, probably undersea hydrothermal vents, that's probably where we came from.
And I will end my session with Neil deGrasse's saying that we human beings are trying to understand on the huge picture up there, even if we don't know what we have under our feet. Yes.
There's an article about arsenic eating bacteria that was, I guess, discovered about a decade ago. And, you know, there was, I guess, just basically six elements that are commonly thought of to be possible for life. Is that right, David?
Oh, 6 characteristics.
Yeah. So carbon,
of
hydrogen,
life.
Right. Oxygen, nitrogen.
Now you're talking about elements now.
Elements.
Well, there are a lot of elements in us, but there are a handful, half a dozen or so, that are critically important. Yeah. Right. And oxygen is right at the top of the list for us. But we're carbon based, if you will, in that we're, you know, our chemistry is based on carbon compounds, i.e. organic chemistry. The term organic chemistry doesn't mean you're buying overpriced carrots, you know, that are the same as the other carrots. It means that we're made out of carbon compounds, our bodies predominantly. That's the definition of organic chemistry.
I see.
That's like hydrocarbons or hydrogen and carbon-based fuel types of like chemicals.
Exactly. And you mentioned that it's funny you mentioned it, getting back to comets and asteroids, Chon particles, carbon, hydrogen, oxygen, nitrogen, heavy, those hydrocarbon compounds are in comets, the building blocks of amino acids, they're out there floating around, not
So
just in
without
us.
comets and asteroid impacts and all the
Yeah.
things, all the ugly things that might have happened to this planet, life would not have occurred.
Well, the late heavy bombardment, this was a nasty, nasty place to be, 3.7 to 4.1 billion years ago. And probably the evidence is leaning toward life got going. It's easy to get it go. It probably got going and was snuffed out by the bombardment quite a number of times.
Yeah.
There are these decades long debates, which are semi-speculative as well, that, comets or asteroid bombardments provided organic matter, quote unquote, which those arguments have lost steam because, everything you need for organic chemistry was already here without that contribution. But how much water, how much of the oceans was donated, if you will, by icy asteroids and comets. And that's maybe something like, 1/3 to 40% of the water on Earth came from comets and asteroids.
Well, the oxygen has to come from somewhere. It wasn't
Well,
naturally
there wasn't there was a fairly slight amount of oxygen compared to what we know of for the first almost couple billion years, and then,
Right.
as I said, by the time microbes, the earliest life on Earth is at least, it didn't take long. It's something like 3.8 billion years old. So life got going relatively quickly after the late heavy bombardment, which was a nasty time, clearing out all the planetesimals in the inner solar system. You can see the evidence of it on the moon still without erosion, but it got going quickly, and then there reached a critical point. There were almost 2 billion years where the only life on Earth were microbes. And there was a critical moment, as I mentioned it again, you can check the Great Oxygenation Event, the GOE. So about 2.3 billion years ago now, going backwards, there was a critical point, a tipping point that was reached where the microbes on Earth were producing enough oxygen that it basically got unleashed free oxygen atoms in the atmosphere. And that exploded the amount of life that could be made, and also tripled the number of minerals, by the way, because oxygen likes to combine with things a lot very easily. You can, if you peel a banana and put it out, on your table, you can see how oxygen likes to combine with things in a couple of minutes by ruining the banana, But so that tripled the number of mineral species from about 1,500 to nearly 5,000 on Earth, the free oxygen. And it also made more sophisticated life easily possible on our planet. We wouldn't be here if not for the Great Oxygenation Event.
I think, David, if a magnetar would come too near us, what would happen to a human being?
There are a magnetar?
Yeah, but too close.
we would have a bad afternoon.
Yes.
And that's something, and Cameron, you were kind of alluding to that too. There are a lot of risks to life out there that have nothing to do with us being really stupid, and not getting along on Earth. There are, there's antimatter, there are nearby supernovae. Of course, there are asteroid and cometary impacts, although we know that there are no NEOs that are civilization killer size. But still, if you have a 1 kilometer rock go in and hit, as close to a city, you got a bad weekend coming, But,
you think, yeah. Oh, sorry, I was just going to. Yeah, I was just going to say that.
There are radiative, terrible problems from close by, energetic stars. like magnetars or other explosive stars.
But the
They could
magnetar, they don't talk about so much. Are they so rare or?
They're relatively rare. Yeah.
Okay, that's why you can't
and
read
there
so
aren't
much.
any near us, now that
No.
we know of. And there are, I mean, we saw Oumuamua, was a little tiny cigar-shaped, comet that dipped through the solar system. Certainly there are interlopers that don't belong to our solar system that come through fairly frequently, probably before we're aware of tracking them, and will continue to. But there aren't any dangerous stars nearby us that we know of in any kind of time frame that would concern us as humans.
If they don't come out, so not Lonely Rider.
Right. But probably, you saw all the nonsense, because this had nothing to do with the core, the dimming of Betelgeuse.
No.
But so that it was all completely hyped into absurdity. But within 500,000 years or so, Betelgeuse will supernova, and that will be bad in terms of radiation, at our distance. Maybe not civilization threatening, but there are threats out there. And then, as we've talked about before, if we survive all that stuff and get along on the planet, we only have about 1 billion years or so left until the sun's increasing radiation will boil the oceans off. And at that point, it's game over certainly for fragile, except for maybe subsurface microbes, It's
interesting.
Life on the planet will be done by then,
The great bombardment that you're referring to, David, I was just thinking when Libby was talking about Jupiter, of course, Jupiter has a big impact. And also think about a lot of the double stars out there and trinary stars. That's you can imagine what that does to the Oort cloud and the accretion disk, as far as the reliability of a stable neighborhood in terms of debris flying around.
That's exactly right. And the early history of the solar system was violent in the inner solar system, but as you say, those planetesimals got cleared out eventually. But Jupiter not only can cast some toward us a little bit, but it mainly has acted like a giant vacuum cleaner in solar system history and sucked up a lot of stuff that would have impacted the solar system but didn't. Exactly right. Yeah.
Didn't the moon kind of do that too? Kind of the last defense for us?
Yeah, and it's smaller, and it took. I mean, Earth took as many hits in the it's believed in the late heavy bombardment as the moon did. And look, we have erosional processes that cover all that up very nicely in a whole multitude of ways. But I mean, look at the moon. Earth's surface looked pretty much like that. Almost 4 billion years ago. We took a lot of hits too, but we weren't around.
Yeah. Thank you.
I took a lot of
kind
hits
of
when I was young,
it's a happy, cheery story. The story of the solar system is.
Yeah, we're very grateful to be alive.
Yes, we do. Yes, we do.
Yeah.
And we have to take care of this planet.
Yeah,
actually, because we have to leave it to the youngest one as we got it, at least not in bad shape.
Libby, it's all up to you after we're gone.
to clean up the mess.
Libby's going to be off planet, okay? So.
Yeah, she's going to be our first astronaut here. Yeah.
Well, maybe what happens to Earth in the future is it becomes like an international park, and you can, if you want to work here, you have to be like a park ranger or something. So, otherwise you might have to be off planet. Who knows? But okay, so we have our next speaker coming up here, and did I get lost here? I think that we are going to transition with Richard Grace, who's got live images coming down. The Astro Beard.
Thank you.
Thank you.
I figured first I'd see if you guys can guess what I'm looking at by the guide scope here. It's in this area.
M51. All right.
All right, let's see. Stop sharing. Start sharing.
Yeah.
So how
Love it.
many images are stacked here?
26. Only 2-minute images. I don't know how straight I'm set up tonight. It's getting dark kind of late, but it's working. We're about to hit the meridian flip here real shortly. So I'm glad you got me in here, and I'm gonna try and find myself another target. We're really zoomed up in this one too right now. I mean, I got something on my sensor or something, but yeah, we're way up on that.
Okay. Awesome. Great.
I just love
Nice to
the
have
structure. The structure, really
some
nice.
clear skies somewhere here on our planet. So that's, it's been so cloudy here. As we transition here to Cesar Brollo down in Argentina, I did want to give a shout out for David Levy's book. It's a autobiography called The Night Watchman's Journey, A Road Not Taken, or The Road Not Taken. It's a fantastic book, a great read, and gives many personal accounts of David Levy's life. Another book we've talked a lot about galaxies is David Eicher's book on galaxies. This is a great, so insightful on the latest findings and goings-ons with research on galaxies. Really, just reading through it really helps you start to figure out your place in the universe. So I think it's very cool. And also just incredible astrophotography throughout the book. So it's really beautiful book. Get the hardcover. I'm not sure if it's in paperback or not, but make sure it's at least in hardcover. And you can find the Galaxies book on Amazon. You can find A Night Watchman's Journey at starzona.com. And so let's go down all the way down to Buenos Aires, Argentina, where Cesar Brollo is out there under the night skies.
Absolutely, yes. In the balcony.
In the balcony.
In the balcony. Yes. Today I don't have maybe so good sound here. It's so noisy, the city, that the noise of the city is completely annoying for me to understand, because today I just don't use the earphones, but okay. But I can hear you, and I hope that you can hear me too.
Yes.
Tonight I started to use again a EX100 that received. Maybe we are the only one store that we have in stock some EX100, because it's really difficult to find it. And of course that, yes, Sherry say yes.
Yeah, they're very popular, and we're grateful
Absolutely.
for all our customers.
Yes.
And
I keep again one for me, because I am how do you say, I'm the service.
now we'll have a lot more in stock here pretty soon.
Yes, yes. And tonight work is a new one, because the last one that I had, a customer says, forget, sold to me, and not to me, to my customer, and I don't have a mount or telescope in the last months. For me, nothing. Actually, I'm happy because I have EX100 again for me, and some stock for the customers. Of course, that I tonight I'm started to use this one, and this I promise that I don't move this from the balcony, from my home. It's for anybody.
So he's there.
Yeah, yes, absolutely. It's the same like your telescope in your backside. Yes. Come on,
Great.
because we are telescope dealers, but we are fanatic of astronomy too, and really we suffer when we don't have equipment for us. This is something that not all people think. And technically, well, I started to use I started to use with the tablet for with a system of that normally we
Explore.
use. That is,
Explore stars. Yeah.
explore
Explore
stars.
Mm-hmm.
That work really fine. I make a single polar alignment and started to work perfectly. And I have some pictures that I can I can show you, because tonight was a little cloudy with a teeny layer of clouds now, because maybe you can see the color of the sky. Well, the colors of the sky in the city are horrible, but maybe you can see some light in any city like Buenos Aires or another city. The light pollution is a nightmare, of course. It's a not new for everyone, for everybody. Sorry. But tonight was a little more complicated because I had this layer of clouds that maybe in English have a name that I don't know, but with the illumination of the lights, this make a very bad combine. But I choose something because in between the buildings, you know me that sometimes I have some targets that are possible to take a picture. Something that today worked properly, really good, was the go-to alignment. First of all, I used the two stars that I choose from the catalog. Something that is great in the Explorer stars when you use or starting to make the alignment, it's that the catalog turn to a catalog for alignment stars. When you with the same, it's very easy because when you choose a menu and choose the option catalog, the catalog that after you use to choose any stars or planet, in the starting of the process is a catalog that do have the option only for alignment stars, because maybe in the why, because in the alignment stars that Explorer stars propose for you in the maybe are beside a tree, a wheel like me, and it's very helpful the option to choose stars in a catalog that is only for alignment. It's very easy, it's very fast, and of course that I choose today. I choose Regulus in the west, and in the south I choose near to the south Canopus. Work properly in a night where you don't see the stars very bright. It's a great helpful to have a catalog of alignment, and was a really helpful and easy for me because if in a night where you don't see the stars or some messier objects in the first view, because you have this tiny layer of clouds, um, trust in the go-to, and when you have the object that you find in in the area of your camera, in the sensor field, you can say, is really helpful. Then the go-to was a great helping for me, and this is why some people choose between only a tracker mount, and you turn crazy sometimes to point your camera with your mount to the object that you need to take the picture. For example, here with a 300 millimeters of focus, the relationship between the sensor size, because this is APS-S, and the 300 millimeters is around like 400 millimeters. It's near to a small telescope, and it's not so easy like you think to appoint an object. And if you have a go-to in your tracker photography mount, it's really a great tool to have more easy or more great results. I can show you. Let me share the screen. Tonight I choose. Let me know if you can see this open cluster. And this is like many times you can see in my pictures sides of the buildings. And this is an open cluster. Open cluster is its number is, let me see, 2516 is in the area of Carina, and it's a great cluster, open cluster, really open, because it's in the farm areas, or where you don't have a huge light contamination, light pollution, sorry, and you can see at naked eye, or you can see very easy, of course, with the binoculars. It's very nice, because it's very similar. Maybe you can, of course, that you know the M44, the beehive clusters, and really is really is like a picture of the M44, very similar to the naked eyes, or especially when you see you watch to the binoculars. And it's a cluster that is around 100 stars. I took these pictures that I finished now to take the pictures, for don't turn crazy to the people. I finished now to make the stack and register, and it's a medium finish picture of this cluster. It's something that is the only thing that I be able to take this picture.
That's a nice cluster, Cesar. I love, this is a beautiful, rich cluster. I mean, you can see it's almost look like M35. You know, it's a pretty good density, right? So it has a nice richness to it, and you're still able to get it in your light polluted skies. That's nice. Must be beautiful.
Thank you. Yeah. And it's nice, because in the center, sorry that I couldn't finish the process, but maybe in this area, in here you can see the difference between the colors. The red star, that is a giant red star in the center of the cluster, And it's really a really rich cluster with the different colors. It's around 100 stars. It's at 400 years. And I don't remember if it's between 60 and 90 million years the years old that have this type of cluster. And I think that this is around this this time. Maybe it's I think that this is the of the growth of cluster that is with 70 million years old. It's very interesting, and is in this area. Tonight was not able to take a picture of Eta Carina Nebula, and really I was a little worried of take again the Eta Carina Nebula. That this is great, really, but this cluster is interesting, and it's nice, and it's something. It's a nice target from the city to shoot. It's really great.
The multiple colors is really nice. I mean, and that's a hard thing to pull out with a picture. I mean, this is where visually you just can't beat it, right? I mean, if you see that visually, you don't blow out the stars and you have this beautiful jewel. I can just imagine the multiple colors. So just like if you look at the center of the double cluster, there's a nice red star in the middle, and it's really nice. I can imagine. Yeah.
Behind it have something similar, and it's something that when you see one or another one, you remember the opposite. They say, okay, where I see this open cluster with a red star in the center, and it's very nice. This is actually how that I using the picture. I can show you if how is the in the live view of this. Let me show you again. Nice view. This is okay. This is Avior. This is star is Avior. Look at how is the picture that we are taking. Now the cluster is behind the building in this area, and this is Avior, the star that is near to this cluster, and you can see the color of the sky.
Yeah. 18% gray.
Yes, it's
yes.
But it's every night is an adventure to try to take something of fun time, and it's great, really. And
you should play around with some filters, different filters.
Yes, I can use. Well, of course that I need to think this year. After the middle of the year, my idea is take some kind of telescope over this mount, but I prefer now explore with the camera, with the mount, and actually we are working in the weekend house of the family, and after,
you're working on restoring that telescope too.
Yes, we are changing the roof. Working the roof. People working the roof, making a new part. And in this area, that is not it's not a high pollution area. It's not. We have maybe a middle quantity of light pollution between the city and the farm areas or mountains, and maybe a bottle, I don't know, maybe two points of bottle less, and I hope to have a new equipment, maybe in August or September to use to return again to a telescope. I have some CDs to start to use, but it's a great opportunity when you have less equipment to start to experiment from the scratch from
Yes. Squeeze
absolutely.
squeeze the
That is
maximum ever get the maximum out of everything you have. Yes.
yes, yes. One equipment that you have and I had and was incredible was, for example, the next image, not the next image, sorry, the evolution. We had the evolution 9.25. But I feel great last year with this month with an 80 millimeters apochromic extra scientific, the FD1 W100, and I really need to return to this equipment. For example, for me, big field and small mount that work
Yes.
properly, I can wide and they have all.
No, that would be perfect because you have zenith, almost zenith view, right? You have like a quarter sky view from your balcony, right? You have a very good angle. Like an altazimuth might not be as good, right? Once you polar align this Exos 100, you can leave it there, like you say, right? And then
Yeah.
just to do it remote, and it's nice. You have a nice little mini observatory.
Yes.
Right?
Absolutely. Yes, absolutely. And this type of mounts are really easy to make a polar alignment. And
Yes.
in my situation, I don't have visible the polar stars or polar very near to use the star. And normally when you use maybe Sherry, remember SharpCam or many programs that have a polar alignment,
Right.
alignment assistance.
Pole master,
Okay.
or if you can see the North Star, a lot of these rely on, but I think SharpCap, you can do an all sky polar alignment.
Yes,
Yeah.
but you need, but in the rooftop of the building, normally I use this and it's really fast because you point one star, another one, it's really fast. The program capture the derivatives in Spanish. I don't remember the name in the tracking variable between the gray, the right polar alignment and another one, the wrong, and you really understand for where or what side you need to move the polar to the polar axis.
Actually, you know what, Cesar? I was just thinking, Jerry had in an earlier session today, was talking about the the deviations. And one thing that I have to say is, think about a polar scope, an equatorial scope compared to an altazimuth. Okay, all you're doing is
the polar scope.
you're changing the axis, right? I mean, obviously the advantage of a polar aligned scope is you only have to track on one axis. So and you don't have field rotation. However, if you're taking short exposures, like 30-second exposures, it's arbitrary. You can do you can adjust the mapping. You could point your polar scope in any direction arbitrarily, right? If you have a TDM, theoretically, right, Jerry, you could just point it in any direction and it will make adjustments on both axes. And then you can optimize the location,
Yeah, the
wherever
right.
you want.
So the Explore Stars does a virtual, I call it a virtual alignment, when the 2 and 3 star alignment, when people talk about, that's a virtual model based alignment, which corrects both, that drives both axes at the same time.
Hi, everyone. Hola, Cesar. Good night,
All
everyone.
right, Maxi. All right. Hey.
Thanks for reminding me again.
All right.
Including when Cesar says to get polar alignment in South Hemisphere, there is a technique that I learned from my professor of physics that told me that we have the Southern Cross, okay? And with the two stars, like Acrux and Crux, with your two fingers, you point those stars and do 1, 2, 3, 4 times and a half, and you approximately you will find the south.
The first, yeah.
Exactly, the celestial pole.
Yes.
But let's say you're on the equator, like Singapore, right? Singapore, you don't have any chance. So you basically you have to point in any direction to minimize the amount of declination adjustment, right? So you don't have to be exactly polar aligned. You just have to make sure the axis is generally close enough, and then minimize the field rotation and the periodic error. But if you have a TDM, and you could be pointed in technically in any direction, right, Jerry? I mean,
with the telescope drive master corrects the PE. But with the virtual alignment, so with the telescope drive master, you need to have a good polar alignment because of the limitations of that box. But in terms of the tracking rate, but in terms of explore stars, you can set it anywhere, and use a guidance scope to correct the PE. But there's a lot of different ways to do things, and sometimes you don't want a perfect polar alignment because you've got limitations of the mount where you want to drive the declination axis in one direction all the time. You want the drift to be in one direction.
You want to keep the deck axis
right. So that loads that loads the deck axis and keeps you from going back and forth. Wes McDonald's calls it crossing the river when you go back and forth. You got a little bit of slop in your gear and you're driving it one way, and then all you got to cross the river to drive it the other way. You know, that's what he. So it gets to be
the river.
That's what he calls it. So that makes it, a lot noisier on the deck axis than you really need to be. So there's a lot of different techniques like that. Counterweight. The way you set your counterweight to bias your counterweight to push against the gear a certain direction. That type of stuff.
Yep.
There's all those things that you have to think about.
Yep.
Okay, guys, so we're running a little bit behind. We have a couple of speakers to get to. Up next is Don Selle. Don is from the Texas Star Party. He's also an astrophotographer. He's given workshops on astrophotography at the world famous Texas Star Party. And Don, I'd like to bring you on now so that you could talk a little bit about what's going to be happening.
Okay. Thank you very much, Scott. I appreciate the invite to come tonight. The Texas Star Party has been a pretty major star party in North America. If it had taken place this year, unfortunately, we had to cancel it because of the COVID pandemic. It would have been the 43rd annual Texas Star Party. It's held in the Big Bend area of Texas. And for those of you who aren't familiar with Texas, the Rio Grande River makes a big loop down in Southwest Texas, and that's why it gets the name from Big Bend, and it eventually bends back up and to the north and out to the Gulf of Mexico. Well, it's desert area, and it's not very populated, so the skies are very dark, and that was the big attraction 40 some years ago to actually get the Star Party organized and for the last 37 or 38 years it's been at the same place at the Prude Ranch in Fort Davis, Texas. The Prude Ranch is what they call here in Texas a guest ranch. everybody else calls them dude ranches. You can go and live like a cowboy for a few days, and that's one of the nice attractions. The Big Bend area also is kind of an international tourist location. There's a really awesome national park, Big Bend National Park, which is not too far away from Fort Davis, and that park gets over 1 million visitors every year, and about half of them are international visitors. So it's a good place to come and see. At any rate, because of the COVID pandemic, we actually had to cancel in-person Star Party in 2020. The Star Party is normally held at the end of April, the beginning of May, and at least here in the U.S., that was last year was the big kind of the big lockdown period. We were very hopeful to have face-to-face this year, but again, we had quite a spike in cases, and we decided to hold off another year on face-to-face. But seeing the example of the Winter Star Party doing a virtual Star Party event, when we decided that we were going to have to cancel face-to-face this year, we really wanted to take on the challenge of putting on a virtual Star Party this year. So if I can share my screen real quick, I'm going to pop up a quick graphic. This is what we're calling the Virtual Texas Star Party 2021. We have a really nice group of speakers, and this is one of the hallmarks of the Texas Star Party. For all the years that it's been in Fort Davis, we've always managed to get quality speakers to come and present to the attendees, and typically there are between 500 and 600 attendees every year, so especially on Friday and Saturday nights, towards the end of the Star Party, we get some really quality speakers in. Speakers give their presentations before it gets dark, and at the end of the session, one of the moderators gets up and says, "Okay, 30 minutes from now, dark rules will be in effect. Let's get out there and observe." Okay, so we're going to try and do the same pattern here with the virtual Star Party. It'll be held on the nights of June 10th, 11th, and 12th. Thursday, June 10th, we have actually teamed up with the Fort Bend Astronomy Club that's in the Houston area, and the Fort Bend Astronomy Club does a tremendous amount of outreach and has for many years. They provide volunteers for the Houston Museum of Natural Sciences George Observatory every Saturday of the year, rain or shine. They have the observatory open. This year, because of the pandemic, they've been learning how to do this virtually, and so they're going to set up, and we hope to have an 18-inch Newtonian, which is in one of the domes there, and then 2 or 3 other scopes out on the deck that will be showing a variety of objects similar to what we're doing here. We'll take the images on the computer and we'll share screens and show you the results. We'll also have a couple of things, other things going on each night. We have every night we'll have a astronomy themed trivia contest. So with prizes, by the way. So we've found a great piece of software that will allow us to have people from all over sign into a website, and it's that particular website will be dedicated to our trivia contest. You can use your smartphone to do the answers, and the software keeps track of who's winning. It's really pretty amazing.
That's cool.
And we're going to have that every night, and we'll have a few other guest appearances and some door prize drawings as well. So just a brief overview of who the speakers are going to be. I mean, you all know David Levy. He generously volunteered to speak. Stephen J. O'Meara. Stephen was a longtime contributor to both Astronomy Magazine and Science Sky and Telescope Magazine. He's currently living in Botswana, and so we'll be his presentation will be pre-recorded, but I know he's going to talk a little bit about doing astronomy in Botswana. Because we're in Fort Davis, Texas, the University of Texas McDonald Observatory is actually only about 5 or 6 miles up the road from the Prude Ranch. And Texas Star Party has had a long partnership with the observatory. We typically every year we'll have behind the scenes tours of the observatory, and Dr. Carl Gebhardt from UT Austin is going to talk to us about the dark energy research that's going on with the Hobby Eberly telescope there at McDonald Observatory. Cool. Dr. Gebhardt is the principal investigator for that project. Larry Mitchell is he's a long, everybody who's been to TSP knows Larry. Larry does our advanced observing program, and his talks are always in demand. People want to get the tips and tricks that they need to complete his observing list in the week. He's also made it possible. We're going to actually run his observing challenge as well as other observing lists. We have a novice and a novice and a deep sky observing list targets, as well as binocular targets, and we'll publish those lists, and you can complete those lists, and we'll make sure when you do that, we'll give you a certificate of completion. So we'll actually have actual observing component of this as well, if you can get out to under the skies and there's no clouds. Stephen Hummel is with the McDonald Observatory. Stephen is a dark sky specialist at McDonald Observatory, and for the last probably 10 or 12 years, the McDonald Observatory has been working on preserving the dark skies in the Big Bend region. And over the last year and a half or so, there's been a new initiative to set up a very large international dark sky reserve, IDA dark sky reserve. It'll be both on the U.S. side of the Mexico-U.S. border, and it'll be on the Mexican side as well, and it will conform with the IDA dark sky reserve requirements, very similar to what the state of Utah is, except it's almost twice as big as the state of Utah. Okay, so Stephen's going to talk to us about the progress that's being made there to get this dark sky reserve in place, and we're really excited about that. So I hope you all will be interested and willing to tune in. Scott's been very generous to allow us to broadcast on the Explore Scientific website, and we're really very pleased and thankful for the support and participation of Explore Scientific in helping us get this virtual event off the ground.
Well, thanks. Thank you, Don. Thank you. Yes, you'll be able to see it on explorescientific.com/live and also on the Explore Scientific USA Facebook page. And we will definitely do our part to help spread awareness of this event. I think it'll be tremendous, and all the luck to you guys, and everybody that's obviously watching right now should definitely sign up for the Texas Star Party virtual edition. So is there anything else you'd like to add, Don?
There'll be t-shirts available for sale too. I mean, what's a Star Party without a t-shirt, right?
That's right. That's right.
Don,
yeah, I mean, you know what? I will tell you that probably a Texas Star Party virtual t-shirt may become a collector's item, because this is a very unusual time. And so I would highly recommend you get one. So
the logo is state of Texas with a mask over it.
Okay.
With the Texas Star Party logo in it.
Just get the t-shirt and have it
crossed out, and it says, "Give me some space."
There you go.
Can I order it to Sweden if I can not make it?
Yes, you can.
Thank you.
We'll be getting the information out shortly about how it'll be pre-orders, and the price includes the shipping.
Thank you.
Great.
Don, I've known about the Texas Star Party for many years. Ever since I was a kid, I always wanted to go, and I'm really happy to be able to join your virtual event. That's fantastic.
Well, I'll tell you what, I'm just fortunate that I ended up moving to Houston for business quite a while ago, and my neighbor 2 doors down was the president of the Houston Astronomical Society at the time, and he's the one that dragged me into the amateur astronomy, and got me out to Texas Star Party the first time. And I actually lived overseas in Kuala Lumpur, Malaysia, for about 4 years, and every year I lived there, I timed my vacation so I could come back for Texas Star Party. It's awesome. if you have I call it my light bucket list. If you have a light bucket list, TSP, do it at least once. It's a really unique event.
Yep. Super dark skies, beautiful. Fort Davis is a great place to hang out in as well. It's just right outside of Prude Ranch. And I've been on the main street of Fort Davis and looked up and saw a beautiful Milky Way. I mean, it's just, you could just set up telescopes right there, but you get out to the Prude Ranch area or any of the areas close to McDonald Observatory, and you've got world-class skies. I mean, it's really cool.
I'm going to share my screen again real quickly, because I want you to understand this Milky Way behind me is actually a picture I took at the Texas Star Party. And hang on, just give me a second.
Hey, Adrian's got to go there.
Okay, this is actually right by the front gate of the Prude Ranch.
Yeah.
Oh my gosh.
And I worked on trying to get this photograph done for about 3 years before I finally got it. And just so you know, I did use a camera tracker to shoot the Milky Way. So I got enough exposure to be able to contrast stretch it as much as I did. So.
Oh yeah, it's beautiful.
Beautiful picture.
Thank you. But as nice as that is, it's just a whole lot more awesome being underneath that the actual Milky Way.
Yeah, you can. The first time I went to the Texas Star Party, I saw what I thought was the Milky Way, but I was mistaking the zodiacal light for the Milky Way. Okay, then as the Milky Way came, I was getting bummed out. This is 1983 when I was there. And I was getting bummed out because I thought clouds were rolling in. Okay. It was the Milky Way. I'd never seen it that intense before. It was amazing. And also on that evening, we got to see Mars. And the seeing quality was so good. It had to be sub-arc-second because it was the first time that I'd seen features on Mars like that. And it was just incredible. And you could tell, I mean, I was a beginner at that time in 1983, but I could tell that the very experienced, because I heard like this hush come over the crowd of people as they were observing Mars. And I go, this is a special night, you know, so.
Wow.
Yeah, and there's lots of special nights at TSP. And so it definitely something you want to go to.
There are a lot of folks who have big scopes. I mean, 25-inch scopes Dobbs are pretty common there, and everybody's pretty friendly and very willing to share an eyepiece, especially if they've got something special to show. So
that's right. Excellent, Don. Thank you very much.
No, thank you, Scott. I appreciate it.
Thank you.
There should be a chartered plane from Europe to Texas Star Party, because there is no flights from Scandinavia to US yet.
Oh, not yet. There will be.
Hopefully.
Hopefully
next year.
So. Yeah.
Yeah.
Thanks, Don.
Okay, so up next is the one and only John Goss. He is with us from the Astronomical League. And John, are you there? He was here. Well, we'll have to see if he comes back. I think at this time we have kind of run over, and we will we'll take a 10-minute break, and perhaps John will be back with us. Otherwise, we'll be coming back to Jerry Hubbell. Okay, and so let's take a 10-minute break, stretch our legs, and we'll be back.
Cesar, can we speak Spanish or not?
Yes, of course, you can speak Spanish.
Okay, Scott.
It's a global star party. You can use any language. It's okay.
Okay, here's Spanish. César, en un rato seguramente se despeje, así que aprovecha. Estás muteado, creo, igual, César.
Yes, now I don't know how it's in Chivilcoy. Chivilcoy is 300 kilometers to the southwest of Buenos Aires.
Exactly, to the west.
Yes, more to the west.
Yes, but let me see in the satellite image. Yes, you have thin clouds, and maybe in your region, maybe 20 minutes, you will have clear sky. Obviously, you have light pollution, but in the zenith, you will see some stars.
Yeah. Yes. Now in Buenos Aires is clean. Yes, we have small clouds, different. Tuvimos nubes, una capa fina de nubes, teeny cloudy.
Typical of the autumn
Yeah, absolutely. Yes, autumn or spring.
And
Yeah.
it's not cold right now, no?
No,
Maybe
not so cold.
10,
Right.
10 degrees.
Yes, no more than 10 degrees, 10 centigrade degrees. Yes.
Yeah. You're going to take some pics with the ECLR?
Do you have your telescope outside or?
No. Tonight, no, because tomorrow I have to work and the clouds will. I have no. I don't. I hate them. So.
No. Yes, it's impossible.
No.
I have a. I finished. I think that I can find. I think that I can share. Okay.
I know we are in.
Allows. Yes, I talked with Scott. Maybe because I have already the picture that I took of an open cluster. But I processed with serial.
You're processing with serial.
Yes, it's great.
Nico from Banfield, Nico Arias.
Nico Arias or Nico Hammer, yes.
Yes, Nico the Hammer.
Yeah, the Hammer, yes. He used a lot of serial. Fernando Ricardini many people mix a lot of different programs, and my idea is explain to the people with only one program, because serial have a great quantity of scripts that you can get to use and to try, especially for stacking. It's a great program, and the process. My son Agustin changed some scripts for when you don't have the flats, for example.
Yes.
Work really good. But tonight I don't feel really trust about my pictures, and I'm stuck with the typical deep sky stacker, but
yes.
Normally I'm stuck. In the last time I'm stuck in with this program with a different using different scripts. You need only, maybe you fill the folders with lights, dias, darks, flat. Yes, and the script make everything.
Yesterday I stuck in Pics Inside some pics that I took Saturday night of M83, M83.
Wow.
And now and then, maybe later I will show the 5 minutes guiding pics in here in my and in the bottom of the sky, but I have some pollution, light pollution. But then I will show you the finally process. I stuck almost 2 hours. I need more information. I need more nights. And I have some issues with the scope that I have a little tilt that makes me the stars straight. And I have a comma corrector and
yeah. Oh, yeah. Yes. When you have the things that appears to
in Newtonians.
Yes, it's absolutely.
You don't believe, but I've been 2 months trying to figure it out. With every time I will collimate, but I couldn't. I have different results, And last Saturday was amazing, and everything was fine. The guiding, the focus, the sky. There was no wind. The night was cold. Maybe a little thin, but very thin of clouds. But that helped me to disincrease the seeing.
Yeah.
And was very punctual. The stars very rounded. I was very happy last Saturday.
I have something little. I have a little of bands in the pictures of that I took today, but I don't know if I can take more because it's impossible to touch more sometimes. I am not a great processing man.
No, me neither. Me neither.
Oh, come on.
I try to process one stack 2 or 3 times to see if I can figure it different process. And some steps I step up, and sometimes I do the first that I do finally, and trying to know the program. It's very difficult, but
Oh yeah, sure.
I think I only learned 10% of all the program.
Yeah.
Maybe
absolutely.
less. I think less.
Yes. No, it's a nightmare. Now I am trying to touch the curves, stretching the image, but it's impossible. From the city is all time is how do you say, it's a nightmare. But my son Agustin knows more. For example, he managed more pics inside, maybe you too. But now I found in Cyril and something of a great program to have something more easy for me, maybe.
Mhm.
Okay.
You will learn. You will learn. Don't worry.
I say okay because I have, well, I have something that I don't know if I have some hot pixel or something, but okay. The fun fact is maybe the microphone is open and the people watch the hair and the letters and are this is why they say okay, I prefer talking English because if we start to talk Spanish or something normally, well, we don't can. Okay.
Well, hello, everybody. We're back. And I noticed that YouTube is back with us as well. And so it's nice to have, our other channel up and running, which is great. We will, I promised that we would bring on Mr. Jerry Hubbell from the Mark Slade Remote Observatory next. And so I'll switch over to him.
Hi, Scott. Hi, everybody. It's been a great night so far. I'm going to share the observatory workstation screen. And I've been earlier on, before the sun went down, I was actually looking at the moon, the first quarter moon. And unfortunately, about an hour and a half ago, I went behind some trees at the Mark Slade Remote Observatory. If you're not familiar with the observatory, we have a fairly restrictive sky where we're at with the observatory. I mean, I can just show you that real quick. I'm going to zoom out here. This is the equatorial view of the sky, but when I go to azimuth view, you can see all this brown stuff are trees.
Right.
And this is the sky we have at the observatory. It's about half the sky that we can observe, but at least a big part of it is through the ecliptic. And we do a lot of solar system object observing, so that helps a lot. And then, of course, during the year, we'll get to see most of the sky as it passes overhead as the months go by. But generally, that's what it looks like. I'm going to zoom back in, and what I'm observing right now is the Virgo cluster of galaxies centered on M86. And you can see it right here.
Oh, yeah.
On the chart. And and this is the most recent picture that's showing these objects. So I'm going to try to put them side by side here so you can see, compare the chart with the
That's
image.
Mercurian's gene.
So you can see M86 here in the middle, and then you've got all these other. I want to specify, I'm not a deep sky observer per se. I like to take images to test things of the deep sky, but I'm not a real good image processor in terms of deep sky objects in color. But what I wanted to demonstrate is this is what images look like right out of the telescope. These are 3-minute images that I'm doing right now. And so this is what people that make beautiful pictures start with. Okay, this is what they look like.
Mm-hmm.
And you can see the amount of detail that you get with just in a single image, with this scope. And this is a 6.5-inch refractor. Let me show you that real quick.
Nice.
This is the Mark Slade Remote Observatory inside the observatory. It's a dome. It's a 6-foot dome. And you can see the refractor right here. You can see there's no dew shield on the instrument because it's long enough just to barely fit into this dome when it's pointed low. So we have to pull the dew shield off because it's too long otherwise. And but it's mounted on it. It's our flagship ED165 FPL53 scope mounted on a Losmandy G11. And it works great. It's got a telescope drive master, so I don't have to do auto guiding. No auto guiding.
I like the on the right there. Those are the eyes. They're called the eyes.
Right here.
Yeah, those are the Mercurian's gene. And I like that galaxy you zoomed in on the bottom there. That's really cool.
That edge on right there. That's cool.
That's beautiful.
Yeah. So let me.
Like a mini M82.
Yeah. So I gotta flip this chart over because
look at all that
this scope is that galaxy is this one right here. So let me flip the chart over to match the.
And actually, if you zoom into M86, if you zoom into it, there's another galaxy set. There's another one right there. Yep.
Yeah.
If you have Sky Safari Pro, you'll see that's another galaxy. That's like a 15th.
Yeah,
15th or
I saw
16th
in
magnitude.
Stellarium last week, and I want to find that I have some trees, my neighbor with the light LEDs, blow my backyard. So I
think it's like a 16th magnitude galaxy.
Yeah. So I think this is NGC 4425 right here, if I'm not mistaken. That one right there. That's kind of interesting looking. It's got good definition.
Oh yeah.
And let's see what else we can find. Then you've got NGC 4388 right here, which is kind of cool. It's got these dark.
Oh yeah, it does on dust lanes.
So this is a 3-minute, just a single 3-minute exposure.
I mean, just think how much fun you can have just with this one image.
Well, that's the thing, and Pekka and me talked about this. This is how you can really do some deep sky observing without having to do a bunch of processing, and just look at the raw images and see what you can see.
Yes.
Which is always fun to discover. And this is really probably the way people ought to start when they're deep sky astrophotography, is just examining the images and see what they can do with the quality of what they're getting, and understand the quality of the image when they're first starting out.
And you have bunch of time to watch the pictures when you have taken those one shot, 2 minutes shot, you can really study the picture what you got,
Right.
and you got the very funny feeling in your stomach when you realize that I just took a picture and I am looking for billions of years old light.
Right. That's really old light. That's right.
And that traveled, and my sensor catched it. Nobody else's, only mine.
Yep. These are my photons.
Yes.
Yeah,
And
there's
those,
a lot of people that have the comment that, well, why would I take an astrophotograph when, you know, Hubbell's made so many amazing ones, and not just Gerald Hubbell, but
That's right.
the Hubble Space Telescope, or, you know, made by big observatories. But Pekka mentioned something that's very, very important. This is a personal record that you've made, you know, when you take your own astrophotograph. And so you can have a rig like what Jerry Hubbell has at his disposal, but you know, Maxie, who's also on the show, is kind of on the opposite end of this. He shows what can be done with a, you know, 4.5-inch reflector and a smartphone camera sensor, you know, and it's really amazing. And, you know, Maxie, I hope you're able to hang on long enough to show some of your images later on in this program.
Yes, of course.
Yeah, great.
So this is all I was going to share tonight. Let's let Maxie show his stuff. And if you got questions about the Mark Slade Remote Observatory, I'll post a link to it, and you can go to the website and look and see what we do there.
I have to say, Jerry, that's a nice gear. That's amazing.
Oh yeah.
It's really
Yes,
nice gear.
definitely,
That's
man.
right.
Yeah, right on, Max.
And
Agreed.
but even as nice as it is, it's really inexpensive with the quality of the imaging that it can do compared to other lot more expensive. You could have a system that's like $1 million, or not $1 million, but maybe $150,000 or $200,000 that this will rival in terms of performance. And this system, if you were to build it from scratch, I would say it's probably a $30,000 to $40,000 system with
Including
manpower and all
observatory.
involved.
Including the observatory.
Yeah, yeah,
Yeah.
exactly.
I got an opportunity to do this with Jerry for a couple of months ago, 3-4 months ago, and it blew my mind. And that night, I decided that I must have a remote controlled observatory.
I just want to show you something real quick, then not to interrupt. I can see the picture. It's got there's a satellite that went through this image just now. You see that?
Yes. Yep.
That's kind of cool.
Elon Musk.
I've had several. I've had several lately where I've had 4 or 5 of them at the same time. I've photobombed by Elon Musk.
Oh yeah, right.
Yeah, I'm going to quickly share something. Let me just share my screen. So this is Sky Safari. So of the same field, Jerry.
Yes.
So that particular galaxy that we were looking at in M86 is actually a 16.4 magnitude PCG 40659. 16.4 magnitude. Think about that in a what was that, a 6.5-inch scope?
Yeah, 6.5-inch scope for a 3-minute exposure.
Yeah, there you go.
Yeah.
And that's that's like a 20-inch, 20 or 22-inch Dove to be able to see something like that in dark skies.
Right.
Yeah. Yeah. I'll just stop sharing.
Yeah, that's cool. That's what I like about Pekka's idea about using this as a way to observe galaxies instead of just doing astrophotography to gather data for hours on end before you get a final image.
Right.
Yeah, and you can do direct vision. I mean, it's a great enhancement, electronically assisted astronomy, to be able to. I like what Pekka was saying. Just have it on your deck. Actually, that's what Cesar's doing too, right? I mean, just have your little observatory there, and then you can look direct. You can have a cup of coffee.
It changed my life totally.
Yeah.
The view of doing astronomy visually, it opens so many different doors to do that.
Yes. Yeah.
You have just, it takes me 5 minutes to rig it up, everything. So I'm ready to go. And I can sky safari every night when it's clear nights.
Yes.
I don't have a session to photograph this and that, and I have to have time to do that and do that. I just surfing on these gravity waves.
Yeah. Awesome.
Yeah. So that's MSRO did a very big impressive on me. So
yeah, and also Pekka, I mean, you and I, we live in rainy areas, right? And
yeah,
and so it's nice to be able to capture the images. You can have a good night, and then you can use the full night, capture a whole bunch of images,
yeah.
and then you can have days and weeks of picking out all the faint objects.
And I just doing my I'm slewing on program or in CPVI or in my hand control. I have a gamepad, and I just slew and look and okay, this is nice. I memorize it. I take a shot, and next, and just surfing around. No directions, just slewing and stop it there. Okay. Nice,
well,
nice.
the other thing, the biggest thing is the workflow as well. And Jerry will really appreciate this, is just to be able to focus on the observation and the record keeping, so that you're actually, it's pure enjoyment and you're actually taking records as you go.
Yeah.
So that it's not overwhelming, right? I mean, it's nice to be able to have a digital record and then just continue to observe and know that you have all that and you can always go back to it.
Before I had a huge stress to be to everything about the electronics and computer systems and making the setup ready and so on. Now mouth is polar aligned, it stays there. I will change the door lock to code, electronics code, so nobody gets onto balcony when I'm not home. So I have told my wife that it's totally forbidden to enter the balcony where I'm not in house.
Yeah, the rule of
because
they
don't know what's under the tarpaulin. I have a tarpaulin over, and they don't know. They maybe hit the counterweight bar, and that's my polar alignment.
Very good.
It's your baby.
Yeah, it's really my baby. It's I see it like not an object. I see it like a almost like a living person. My wife asked me that a couple of weeks ago, "Who are you talking with?" I'm just talking.
Okay.
Yeah, so that's all I had. I put the link out there for everybody.
And I put it in the chat. So definitely visit the MSRO and check it out. We have seen some really amazing stuff come from there, and we'll have to have the MSRO team also was a host of Global Star Party. They'll have to do that again so we can learn more about what's going on. Up next is Cameron Gillis, and he has been steadily educating us on the attributes or the good points of reporting your observations. And he's been on a mission personal mission to do this sky survey, but he's observed thousands of objects. He's very knowledgeable about the sky. And so I'm going to hand it over to you, Cameron.
Thanks, Scott. So I'll make it short tonight. Basically, just an update here. Let me share my screen. I'm going to reuse some of the stuff from Global Star Party 45 on the weekend. Let me just. So yeah, so I've been using a combination of. Let me just. This is good enough, I think. Yeah, combination of a wide field ED80, of course, my Mac 102. And my smartphone, and basically, like what Pekka was saying, just kind of taking pictures, over the last year and starting to do a survey, and then I also have an 8-inch Evolution 8 C8 with a number of eyepieces, and again with the smartphone. But the biggest thing is the tablet piece. With Wi-Fi using Sky Safari. So basically, what I've done is I've coupled Sky Safari as my record keeping tool, and if I open it up, if I show you what I was showing you earlier, let me just go back here. Basically, with Sky Safari, you can actually have all your observing lists. Let me just looks like it's a little bit. I'm going to just zoom out here. I'm using Sky Safari Pro, and over the last year, I have been basically creating observing lists where for every constellation, and down to 13th magnitude, all the objects for every single one. I started with booties about a year ago. And what I've done is started to look at each one by one. So for example, if I open up booties, I guess is the proper pronunciation, and I highlight the objects. So this is the list of 55 objects that are down to magnitude 13.
Wow.
And out of those objects in booties, I go object by object, and then I take a record. Like in this one here, this is a 10.1 magnitude galaxy, and if I look at the observations, it should be coming up. It's a little slow today. Oops, I show observations. So this was done in June, almost a year ago, 2020, 10:50 in the evening. It's just an oval patch. So I've done some, and what I've noticed is, for example, even though it's magnitude 10, this was a pretty diffuse oval patch. And then there would be another one. I close that. Oops, sorry. And what I've done is, after I've observed them all, and I go pretty specific to every one. I triangulate. I do a visual plate solve. So, for example, on that particular object, if I zoom in, I'll just zoom right in. What I'll do is, I have my field of view here is my Nagler 13 millimeter, which gives me 156 power and what, a half a degree. And I'll start, I'll do my visual plate solve, and I say, okay, there's 2 stars here, 2 stars there. Therefore, the object is here, and I use averted vision. And this is a fairly large and diffuse galaxy, even though it's a beautiful galaxy. If you have probably taken an image of it, or you have a larger aperture. But with my light polluted skies, I wasn't able to resolve it very well. So what I did is, it didn't make the cut in terms of what I call best and brightest. So if I actually now go back and I go observing lists, I have my best and brightest, which has 681 objects that I've categorized. I go through, after I've went through everything down to 13th magnitude, I go through the constellations, and I look at all my observations, and I start saying, okay, which ones do I want to reobserve that are bright enough to be able to see on a smaller scope? And you'll notice that didn't make the cut. So this one here, NGC 5490 made the cut. So if I go zoom in, there's a lot of other galaxies. This is the fun part because right now this is just an observational survey, but I'm going to extend that survey to include imaging. I'm going to start taking imaging where I'm going to, what we talked about earlier. You'll start to identify other galaxies in there, and that's the reason why I have the fainter ones. But what I was able to observe, 5490, and let's take a look at the observation. That was also done on June 22nd last year. And take a look at it. I call it a distinct oval. So that means I can actually see that. And in some cases, I might have a distinct oval with a brighter core. Let's go to another one, for example. Let's go up. Let's try this one here. And we'll go show observations. That was done on Monday, the 29th, about a year, fairly bright oval. So that's a little more distinction. And basically, what I've done as recently as last Thursday, if I go to my observing list, I was in. Let me actually go back. I look at my observation, my session observations, total observations, all observations over the last year. I've done 2,878 observations, and they're everything from oval patch down to beautiful bright oval with, distinct structure or a dust lane or whatever. So I'm finding all the nuggets as I go through and I browse and I do my sky survey. I start to find some really nice objects. So for example, I go down to what I did last week. Oops. Move this away. And let's go sessions. So my latest session was a very good one. Last Thursday, I actually it was a beautiful night before the storms rolled in on the weekend. But I got 121 observations in. And what I was able to do, if we look at that, I was actually completing my survey. If I zoom back out here, you'll notice
that's a big percentage of your overall population of observations. That seems like a lot.
Yes, it is. I mean, if you average it out, 2,800, let's say that 26 weeks in a year, so that's an average of 100 observations per week, right? Roughly is what I've been logging.
Prolific.
On an average.
Yeah.
Yeah. Now, obviously, what has happened is in the wintertime here in Seattle, you can forget it. I mean, I might have got 100 observations over 4 months, but in a couple of weeks ago, I was in Virgo, as you can see, and oh my gosh, I had a heyday. I had like 4 consecutive nights where I was able to really, and there was like, if you look at Virgo, the list, it was around 300. There's 300 objects down to 13th magnitude. I actually observed them all, and out of those, you can see a lot of them made the cut. There's actually a lot of beautiful nuggets in Virgo. Usually, Virgo overwhelms a lot of people because it's just so. Oh, let me just check something here. Can you still hear me?
Yes.
Okay, good. So usually Virgo is so overwhelming, you focus on the big things like Markarian's chain and some of the Messier objects, but there's some other very beautiful galaxies as you start to, methodically drill down and see some of the brighter objects. Some of them are actually surprising that Messier didn't discover them, back in the day. But so it's kind of nice to be able to go through that and then be able to say, okay, these are really good candidates for anyone to look at with a small scope. So I've done that, but if you zoom back out here, you'll notice that if I change the time, let's go a little later. There's a big gap here over Libra. That was a constellation that was missing. And then I also, over here, if I zoom in, I also had Camelopardalis. Here we are. Camelopardalis is a big hole. But what I was with those 120 objects I did on last Thursday. I go to observing lists, and then I go to Camelopardalis. Scroll down. Here we go. 59 objects, and I observed them all. So if I go to unobserved, I saw them all. And if I go like this and I go highlight objects, go back, you'll notice that these are all the objects that I observed. So I actually knocked off, before these guys went into the western smog of Seattle, I got them and I kind of started combing through them gradually as the Earth, of course, rotate, and I managed to get them all before by the midnight. And then after I did that, finished that.
Cameron, we're losing your audio. Hello? Yeah, Cameron, I think we've lost you. I think probably, why don't you try to get your audio fixed again, and we'll transition over to Richard Grace at this time.
I'll be quick anyway. Let me get this thing working here.
Yeah.
All right. Here we go. I'm back. Oh, where's
first YouTube, then Cameron. But YouTube's back online at this point, from what I understand, so that's good. Wow.
Whoa, nice cluster.
Got a little bit of M13 from the backyard here.
Yeah.
Portal 6, we got a LED street light 100 feet away, and we're making it work. And
wow.
you can see the propeller a little bit in here. I think that's it right there.
Yeah.
I ironically went to Markarian's chain and it just wasn't working for me. And good timing for me to switch to something else too, because Jerry already got it for me, and that's awesome. So just thought I'd share this.
Very cool.
And it's
awesome.
I
got my.
Are you back?
Can you hear me again?
Yep.
Yes. Yep.
Yeah. Okay. Sorry. Yeah. Very good.
It's getting towards late for me. So it's probably be my last one, and I'll catch you all soon. I'll be hanging out, but
Richard, thanks very much for coming back on. That's great.
Hey,
we missed
no
you.
problem.
Yeah.
Well,
very cool.
Thanks, Richard.
Got some stuff done, and I'll see you guys more often now. We got a lot of work done up north.
Yeah.
Alrighty, I'm gonna stop sharing and send it back to you guys.
Yeah.
I'll just finish my thing quickly. I'm almost finished. Sorry. Let me just. So as I was saying, you can see my screen again.
Yep.
Okay. So yeah. So finished with Camelopardalis, and then I actually got into. I go to my observing lists again, down to Libra, and Libra was the last one. Oh, actually, it's right up here by booties. There we go, Libra. And then basically that constellation has, to go back, Libra had only 27 objects. And then so I was able to get, and what I've noticed is, again, even though I did the categorization down at 13th magnitude, where I'm at my latitude, I'm 47 degrees north. So some of these lower galaxies, they're kind of in the mud. And so the surface brightness really suffers from light pollution on the horizon. So I really noticed that I have an Altaz go to, and if I go all the way up here to the zenith, where of course is the best clarity and minimum light pollution.
Right.
That's why I want to get an equatorial mount, because then I can really start to maximize the view, right, and start to see the fainter objects. But I'm still doing my due diligence, doing all these all the galaxies that are on the horizon. But the nice part is, for anyone who has more favorable latitudes, including, of course, the southern hemisphere, you'll be able to see this. And if I can catch it in my polluted skies, then there's a good chance that you'll be able to have a much better view. Anyhow, so that's kind of the latest. And again, just pure observation right now, some smartphone on some of the brighter objects. And then I'm going to come through again and do imaging similar to what Jerry showed earlier, more like a sky survey type of imaging of all these, and be able to categorize so that anyone can have their own list and say, okay, do I have a chance of seeing that object or not? Anyhow, so I'll just stop there, and thanks for letting me please share.
Thank you, Cameron. Thank you. That's great. Yeah, and so tomorrow, Cameron will be back on our program with First Light Chronicles with Camstronomy to learn more about the adventures of Cameron across the universe here. So up next is Maxi Filares, and he is a genius with the smartphone and in astrophotography. And he was introduced to us by Cesar, which was great. And so we're glad to have him back on the Global Star Party. Maxi, it's all yours.
Thank you, and good night, Scott, and everyone. Thanks for inviting me again. So basically, the last time I've been here, I was show some pics that I did with my smartphone, doing in two ways. First of all, like we all do, I use my cell phone, like my eye, to put it above the eyepiece and take pics with some seconds, and then start to get a guiding and have more seconds to continue to stack and process the images. Then I do an experimentation where I suppose that I took out the lens of an old cell phone and to do planetary images, doing videos. And with another cell phone, I did some deep space images, taking almost 30 seconds of images. Let me show you some pics that I have in my Instagram. So everyone has want to do or introduce to do astronomy or very amateur astrophotography, maybe can help to start and encourage to do it. So let me see. I don't. Okay. So this is the screen, and do you see?
Yes.
Okay. Well, this is now was with the cell phone. This was December 14th in the Valcheta eclipse. I was a few miles, no, maybe 1 mile far away from Cesar. I was with another group, and this is a real a dream come true. Okay. I always want to take a picture and see an eclipse, and this is I want to show you the 2nd of July in 2019. This is a GIF that I do with all the images that I took. You can see the this is I took with with my smartphone. See all the pics that I take every time, tack, 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 and I do this animation.
Oh, yeah. You got it.
Oh,
You can
beautiful.
see the
Awesome.
horizon.
I love that. That's cool.
That is
and
awesome.
and they show up and again the sun. This is the 2nd of July. Well, some examples that I did with my cell phone doing my about the IPs was the Sculpture Galaxy. Okay, this is was
look at that
with a
detail.
Mac 102 with I think it is F13 about the 25 IPs. And this is the Mintaka star and the Flare Nebula. This is one of my first images, and the stars. No, sorry, no, Alnitak. And this is a very difficult
Oh yeah,
object.
Gillis.
Nice, very nice.
Very nice.
Here's the center of the is a dwarf white, right? No.
Amazing, you got color in that too. That's really good.
Yeah.
All this I did in my backyard. I have Portal 5. Maybe some nights, maybe 6, and now with some LED lights, I think I have some issues. Okay, I'm going to show you my Instagram. I remember the Saturday, Cameron. You show us some planetary nebulas, and this is the Goss of Jupiter. Okay.
Yeah, nice. Yeah, I recognize it.
Oh, look at
And
that.
here is zoomed.
Wow.
Yes. Perfect.
That's incredible.
The color is nicer. You have a nice bluer. Mine is more greenish.
When I process in PixInsight, I use a tool that took the green out and gives more reality, but it doesn't really exist the color of reality. Okay, but
That's really good.
it's going okay. This is some pics that I did with my cell phone above the eyepiece. This is a Horsehead Nebula.
That's a hard shot. That is a hard shot to take.
Okay, this is not very good pictures, but you can do astronomy with this. You can show us, you can show to everyone what you are looking at.
Yeah, I mean, I mean, what size that Horsehead picture? What telescope did you use?
I use the Maxutov.
The 4-inch Maxutov. Oh my gosh! So, you know, you can, if you're lucky, again on a dark sky. What do you think, Scott? Maybe you need at least like a 16-inch or something, right?
To see the
Horsehead.
Horsehead. I have from very, very dark skies seen the Horsehead
With your 13-inch?
through an 8-inch
telescope.
telescope.
Oh, an 8-inch. Yeah. Okay.
Yeah, but it takes extremely transparent, extremely dark skies. I did that from Rodeo, New Mexico, and it was, you know, it was the kind of sky where the Milky Way is casting a shadow.
Oh, wow. Yeah. So, you know, just think about those conditions compared to what he took with what Maxi took, right? With a 4-inch.
Right.
It's like,
I know.
Wow.
Well, this is the Galaxy Centaurus A from the South Hemisphere.
I've always wanted to see this.
Yes, this is a really good galaxy. I can zoom. Yeah, right there.
Yeah, excellent.
And this is with the same here. Let me see. I got Max 2000 focal length, ocular Kellner. So well, here's some friends. Well, then in the last year, I can progress with the scope, and I turned to a DSLR camera to get more field, to get more light, to everything, to progress. But I want to show you all this to everyone who can start, and you can say you can do it. You can look at this cluster star. This is 47 Tucana in the south. You are seeing a lot of suns compressed with gravity and density and the light, and grabs you. Here's another nebula, planetary nebula, the Dumbbell. This is with the UHC filter,
Nice.
and also the Maxutol.
Mm.
Okay. Well, this is the Tarantula Nebula here from the south.
Yes.
And when I process these pictures, the little red stars contrast with the all of the clouds and everything. This is a little dark point right there, and this is amazing.
Wow.
Well, back doing recording with the video with the cell phone without the lens, now with the eyepiece, and I am going to show the difference. Okay, how it see. But this is a Saturn with the Maxutol and the cell phone. This is with yes, with the Huawei Plus with the Barlow and at primary focus. This is without the lens. Well, this is the moon doing some stacked images with quickly shots and maybe 2 seconds of shots, stacking it. And this is more Jupiter, Saturn, and well, some occultations, the Saturn, and the moon. Here's some of the moon too. Well, the eclipse. So basically, this was 2019. Then I start to practice to do pictures with the Newtonian 115 NF5 and the Huawei without the lens. So you can see in here, I did this with the DSLR camera from my backyard, okay? But in this case, I did this with my cell phone without the lens. Look at the zoom and the details of the clouds and colors and stars. You can grab it. Also, I did the Trifid Nebula with the cell phone. Only put it on the focus.
So do you do that the same way you do with an astronomy imager, right? You basically couple it with a Barlow so that you
no.
get,
This is what primary focus, because the Barlow give me more lens. The cell phone has a little sensor like a planetary camera, but the program and the sensor helps me to do 30-second pictures. You can do it with your smartphone, and but the diameter of the telescopes and the zoom that I get gives you a less light than doing above the ocular projection. That's another way, okay?
Right.
And I think you are doing that, Cameron, right?
Right, I'm using the eyepiece, yes.
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 I did some techniques to get focus, to put the eyepiece very good above the ocular, and to give you more field and less obstructions, astigmatism of the eyepiece and everything, and reflex. I use the clean lens, el trapo, ¿cómo se dice, César? Está muteado, está muteado.
Oh,
a cloth to clean
cloth.
A cloth. Yes.
I put it above the cell phone and the eyepiece to get less
Oh, yes,
light
straight
pollution.
light. Yes, avoid the stray light. Yes, stray light coming in between the eyepiece and the.
Exactly.
Yes, very good. Use a cloth. Yeah.
Exactly, like all cameras, like in the 19th century. Okay.
Yeah, where you wear that cloth.
Exactly.
Yeah.
But not me. Only in the phone, about the phone. But
very good. Smart.
And that helps to take a more clean picture. And I have some issues and practice and headaches and well, everything you can imagine. But at the end, you can still do astronomy.
Oh yeah, very good.
Well, here's a Venus that I did with the Maxutov. Here's the cell phone. Well, this is my backyard, my dogs, and this is in the maybe 4 p.m. Last year. Here's my mom that I was seeing Venus, and here's the Maxutov, and here's the Barlow 2X and the cell phone to give. Oh, sorry. No, acá. Maybe the focus maybe wasn't so fine, and I have a scene very regular, bad. And remember, I'm using a Maxutov with a very zoom area, and in the afternoon.
That's hard. Yeah.
But
wow.
Okay. So basically, I still progress. I captured the last year supernova in M61, but I'm still doing 30 seconds of picture because I haven't a guide scope. I haven't an intervalometer, but I can do some shots of some comets. This is the C. 2019 UC Demon. Well, my dog Luna.
Cute.
She is every time I grab the telescope, she's behind me, and I'm go inside, and she's still there, doesn't move. She doesn't move. So more early I told you that I have a Bortle 5 and I'm doing 5 minutes pictures. And this is, oh, sorry, wait. This is what I get in every single picture. Okay. It's at 5 minutes with the, with this scope. This is a 2000 F4.
So the sky looks blown out. It's just,
yes.
Right.
Yep.
Okay, but when wait a minute.
This is for the Nikon.
The last Saturday night.
Yes.
This is the difference what I get when I start. Okay.
Oh.
Nah,
good
the
processing.
The process, yeah.
Good processing. Very good processing. So you must have you have like a macro that you've come up with, a script to do this, or do you do it all manually?
No,
how many hours?
I've been hours. I started yesterday. I was the first start that I did with Pics Inside, and then I tried to clean with the DBE to get more flat the fields and reduce the noise and everything. In a moment, I showed to Cesar also the Sombrero Galaxy, but I didn't finish it yet. But in a Portal 5, you can still do astronomy. And I saw people from Buenos Aires and some friends from Gran Buenos Aires, from the outside of the capital city, that they do pictures from their backyard with LEDs, lights, and a lot of contamination. Let me show you a minute. Wait. Acá. From the light pollution map, this is where I am from, and this is where Caesar's is right now.
No, for me,
Geez.
where I am is impossible. Yeah. After
Okay.
you, I have ready the open cluster picture, but I keep the program keep tons of background light. Tons.
Okay, my internet is at with a wheel.
Welcome.
Oh, I'm in Africa. No way.
Yeah.
Okay, here it goes. Okay, so this is Argentina, Buenos Aires, and here's Cesar.
Yeah.
There.
Middle of the explosion. Yeah.
Wow.
And I'm right here.
Hi, I'm here.
So in this is city Chivilcoy. It's a small town farm, but when I go out maybe 10 kilometers, I can still do more pictures. But I'm also right here. I can do only the north and the northwest and the northeast. The south from where I'm right now is too difficult because I have all the light pollution of the city. So okay, that's it. Okay, so this is my resume to everyone. If you want to ask me how to take pictures with the cell phone, if you have a smartphone, you can talk to Scott, talk to me, or Cesar. I encourage to everyone to do astronomy because this is fascinating. I started 3 years ago, and when I was a kid, I always want to do this. I saw the Hubbell pictures. I don't know if I show the Cosmos book, but I think I did. I don't remember. No, I think not. I have this Cosmos book of Carl Sagan from my father, and I like everyone saw all the pictures of the galaxy and the nebulas and everything, and I saw one time a picture of M42 and realized that I did that a few moments later.
Right.
And I have printed by a friend. So that's amazing. All the existence that surround us. And today with David, you're talking about the outer space, the perhaps of living lives, all of lives. And when I see the Milky Way, for example, or see the stars in the farm, you can, I think, the tiny thing we are and the fortunate we are, and we have to be here right now.
Yeah.
Okay, so I'm stopped to share.
Maxie, that's very, I think that's something that all of us share the feelings of, that are astronomers. And, it's nice to hear people express it and try to share that with the rest of the world. So thank you very much for coming back on. We did have a question. Somebody wanted to know if you had a photo of your cell phone conversion. I think you showed it.
Yes, wait a minute. I'm going to wait. I have did this with the Samsung S4 to do planetary images.
Yeah.
Okay. I did a PDF show, tell a little story, a little briefing of my experience. Let me show you again the screen, and you can text me, and I'm glad to send it. Okay. Sure. So this is ahí está. En España, astrofotografía con celular modificado para foco primario, o sea, astrophotography with a cell phone modified to primary focus by me, speaker. So what I did, I disarmed in grass of parts the cell phone. This is the principal placket, and I don't know if it says like that, but this is the part of where's the camera, and here you can separate from the principal main. So I disarmed the camera lens. Okay, with the maybe a little not fashion way, but doing a little force to take out this metal cell, and there is the lens of the camera. There's some little balls that give you the focus when you touch the screen. The camera goes to focus. This helps to go forward and backwards. So when I took the lens, you can see here you can see the lens clean, and okay. Yep. So I armed again, and I did when I started up, I thought that maybe I broke. So no, let's try to again in the scope. But I did this case with a silicone protector and the old film camera that fits perfect in the eyepiece. So I took the scope, and you can see this is the max setup. I have a lot of focus. I was trying to get focus, and I can see anything. And then I see this, and then, what is this? This is okay. But I start to move, and I can see the block of my wall and the tree. And no, I did that with another.
Without the air filter. This is why the color of the tree is white, maybe. Yeah.
No, this is the hoja, la hoja, the paper. No, the tree.
A leaf is a leaf of
a leaf. Yeah. Of in the autumn and winter when it was dying.
Maybe it's the real color. No, sometimes when you maybe you remove with the lenses the air filter, and normally when you shoot a leaf of a tree, you don't see in color, green color. If not,
more
picture is
more
white,
strong.
normally. Yes, or another color, but not green.
So when I start when the night comes, I put the cell phone and the Maxuto, and this is Jupiter. So I did with everybody do a video or some videos of Jupiter. So when I stack them and process them, I can give this.
Quality is amazing.
This is what
Nice.
almost in the opposition, the closest moment between the Earth and Jupiter, so I can grab some details, some storms. Today, Libby was talking about the great red spot, and
Awesome.
this is the moon of Io. And then I did some lunar pictures. You can see the happening mountains, some creatures. I think this is Plato. No. Maybe correct me if I'm wrong.
So all these pictures are with the modified
exactly
cell phone, right? Yes.
It's awesome.
with the Barlow.
Yeah. This is what you're
And
talking about, Scott. There you go. It's
Yeah.
have to have a new modified smartphone if somebody.
That's right.
and you can with the advantage to use a smartphone, obviously not with that one you have in your pocket, maybe with some older smartphone, but you can share to everyone, because when you are when you get focused seeing what you're seeing, the moon, maybe the sun, obviously with a filter, or a planet, you can share it in Facebook, you can share it everywhere to show everyone what we are seeing in this night. You are seeing a big giant planet, you are seeing maybe an opposition, you are seeing an eclipse in the surface of Jupiter, for example, and this is amazing. This is, for example, the what's the
Good job.
what's the an occultation? You can see 5 a.m. of the morning, the Tuesday, 16th of July in 2019.
Nice.
So last year I was progressing with another cell phone and the Newtonian F5 with a Barlow 2X and the Barlow 3X coupling. Put it together.
Yes.
Okay, so I can have 5x of zoom. So when I did Jupiter, I can do some animations of the rotation. Let me find if no. You can see I have with the date of the astrofotografía 2020 and all the month. Let me remember. Yes, was in. So no, well, this was dark sky. No, Jupiter, the rotor. No. Well, or for example with Mars. October here. This was some videos that I did in Mars. This is last year of Mars in the opposition.
Wow.
Oh, awesome.
Super.
And let me find, no.
My God.
Super.
No, this
Super,
is.
yes.
You got some good records too. This is awesome.
And everything was with the cell phone. I don't remember where I did where I put the animation, because that was oh, sorry. Maybe it's here.
So all the planets pictures, you use the Barlow technique, right? A direct with no did you use any IPs or just direct?
No,
Barlow.
only the Barlows, and sometimes I use the how he calls the filter, the polarized filter,
Yeah.
to get a less of brightness, because sometimes the cell phone can't take a lot of the bright of the planets, and that helps to see more details. So
That's a good technique. Yeah.
no, this is taking. Well, I don't remember what I have it, but here's some example with Jupiter, with the Hawken 150 and Barlow 3x and 2x. You can see more details in here. The great red spot, some storms here. So I don't know where. Well, Mars. I don't know. Well, this is with the DSLR, Sculptor Galaxy. I changed to get progress, but I enjoy all this trip to get where I am right now. I didn't start with the best telescope, with the best gear, with the best camera, because it's like you are in school. You start in first grade, second grade, and everything, and you're still learning, but step by step, not everything. Okay.
And you're stopping and smelling the roses. You're enjoying the whole journey. That's nice.
Yes,
Yes.
I think that's the important part of the journey.
All right.
That's the learning curve, because my daughter was traveling, I don't know, Turkey or something, a couple of years ago, and when we talked, she said it's so exciting, and she can't wait and wait and wait. Every day is only waiting, and I told her that stop, because that waiting is third of the whole experience. If you have no waiting and learning or something, and you just get everything immediately,
you don't enjoy it.
No, you don't enjoy it as much when you are learning. It must have that hard part before.
Oh yeah, there's no game.
There is no game.
Yeah.
When you think you are expert and you don't learn anymore anything, I think the journey is over. You don't have anything to experience anymore, because in astronomy there is no end of learning.
No. Always you're still learning. I'm still learning a lot of things.
Every time you look on the sky, even if you look the same object, every time it's a wow experience.
Exactly. I don't know if you feel the same, but when here in summer we have the Orion, the constellation, but you have the winter. But when starts the winter here, you see, oh man, the Scorpion, look, the galaxy, the Milky Way.
Yes.
And you were missed of those constellations and those skies. Then in September, maybe you are a little, maybe, no, you don't care, but you don't give it some importance. But when you see again Orion, oh, the summer skies, oh, and
for me, it's even driving a car at night time in winter. I have to almost stop because when I get outside the town, it's so dark that I can't drive. It's impossible not to look up.
Yeah. No, no, no.
And everybody in the car, what are you doing, Pekka? Look at the road.
Yeah.
And I'm looking upward.
Well, you have rows with two roads to go and two rows to come. Here
Yeah.
are one
Highways.
and one.
Yeah,
Yes,
here
but
too.
in Argentina,
It's
No.
very dangerous here.
single road. Yes, yes. We
I
love
have-
the adventure.
Tesla. Tesla is the solution. Self-driving Tesla with open roof. So I can sit in the back seat and just looking.
Yeah.
Well, this is again some single pictures of the eclipse of December.
Mhm.
In May, next week we have the moon eclipse.
Yeah.
Here are being 6 a.m. and Tuesday we have a holiday because it's a patriotic day here in Argentina. But
By 20
in Wednesday I have to work, but I'm going to wake up maybe 4 a.m. to go maybe a little.
In fact, Maxie, you're reading my mind. I just finished the announcement poster for the next week's Global Star Party, and it lands on the night of the 25th and the morning of the 26th. I am thinking about contacting some astronomers that would like to live stream the total eclipse. So I'm hoping that anyone that's listening here who would be interested in doing that and participating in that would contact me. And it would be quite early in the morning for me to broadcast that. But I'm thinking maybe of an evening pre-show, to get people to understand how to photograph an eclipse or, this kind of thing. And then that, maybe I would take a nap, and then that morning early, I would start the stream live again, and we could see the eclipse for people who might be clouded out or unable to experience it. So.
Yes. And here we have some issues from the policy because we are we can go out at the 8 p.m. Until the 6 a.m. of the next day.
Okay.
For the COVID situation, but is in that moment when here the eclipse starts.
Yeah.
So maybe let's see how's the weather in some maybe Monday.
Sure.
But I don't know if Cesar has a better see
Yeah.
because he is up in
He's up on his balcony.
Yes,
Sure,
I know. I don't have it.
But yes, but it's when the moon rise in the rise. I think I don't remember the position of the moon for that day. But first of all, we are expect rain weather for May 23, my birthday, on Sunday. 24, 25, maybe 25 it will be. Maybe in between 24, 25 the rain go away, is finished and return cold, great weather with clear skies. But I don't know. Wow, this one is really. I don't know what of course that I put my picture after see your picture of the conjunction. I put my picture in a box.
This is awesome. Yeah, you got it right on the closest
yes.
approach.
This is my brother Christian. This is me.
I know your brother.
We
in
go
safari.
to a road with a farm. We put the gear. This is my car.
The Argentinian Pampas.
Exactly.
Really flat, like Texas.
Nice. That's awesome. Great location.
Now,
For me,
mountains in many kilometers.
For me, Argentina means football WM 1978 and Mario Kempes.
Oh, yeah.
That's
the World Cup.
Yeah, that's Argentina for me.
El Matador Kempes. This is outside of a field road, like the grab, and we put the gear to see the conjunction because it was very at the afternoon. So here's my brother seeing the sun with the filter. Of course, no like naked eye. So I took this picture of him, and here's the conjunction. Here's the two planets. Here's what I see in the images of the cell phone. This is a Huawei without the lens, and a Barlow 2X was with this.
Wow.
You can see Saturn and Jupiter and the moons.
Yeah.
And this is more later. The light was of the moon, but this is the contamination of cities like Carmen Areco, Rawson. Well,
Yeah.
this is the north, and maybe I don't know. No, but I can see it. Oh, sorry. No, because from this way, I think it was the Andromeda Galaxy. From I don't know if it's this. I don't because no.
For us, it's really to the north.
Yeah, you will have to see upside down, and maybe you can see the stars. But this is how
we have a picture of Andromeda, Maxi.
Yes, we went with also with my brother. Well, this is again the photo that I can took. Maybe it's not the excellent picture with the very good gear, but you are doing astronomy and you are capturing this event that happens a lot of years in one time life.
But Maxi, that picture that I want to say something. I mean, the trick that you did. This is actually an excellent picture, simply because it's very hard to get Saturn bright enough, and also the moons, because Jupiter usually blows everything out. So to be able to see the bands, the moons, and the rings, and that's a feat. That's a feat with any instrument. So that's a good job.
Thank you, Cameron.
I recognize it's really good.
Well, this is a picture of. No, this is a single picture. When we were.
I can't wait to get a picture like that. So
a
nice.
farm. This is with the Hawken, a Newtonian, and I don't know. I think was 45 minutes of pictures.
This picture of Andromeda from South Hemisphere is impossible.
We have
that Maxi Falieres going to post something in the social media of astronomy, our Facebook, we are scared about.
No. I'm just only an amateur astrophotographer. There's a lot of people. Maybe Andromeda. I can do better. Maybe, and it's amazing. I'm doing this with passion. I'm doing this to everyone to show what is around us. Okay,
yeah, Maxi, that's not the point. Because I have thought about this a long time now, and when I got to astrophotography for 1 year ago, I was blown out about those very professional pictures,
Mhm.
but I think they are putting the whole soul for just taking those pictures, and the observation and the real astronomy is the second part of
Yes.
it, because they can't make everything. I think that for me, it's for me, do one thing properly and good, and do not do or do 10 things quite good. So I am doing 10 different things, but not really good everything. So I can combine everything, because if I just taking really, really, really good pictures, it will take my whole time just to take that picture, and I hadn't time for the rest of just like making visually and just star hopping and so on.
Yeah,
So,
no, I agree, Pekka. But I'll also say that it's awesome to have I think they really complement each other. So I totally agree. I'm on the same page as you as far as just taking a lot of like basic quality.
Yeah.
But it's really good that there's people taking awesome pictures too.
Absolutely,
Cause
absolutely.
you remember when we were kids looking
Yeah.
through the magazines and looking through that, it's like,
oh
wow,
yeah,
you know,
oh yes,
like,
oh yes, oh yes.
So it's nice to have both. Actually, what I'd like to do, Pekka, and you're probably thinking the same, is have the same object and take all the different quality, right? Like the basic, right?
Yeah.
All the way down to the like Hubbell quality, right?
Yeah.
And see what kind of detail you can see at every level. And it's amazing what you can see with even basic shots, like, you know. So
Yeah.
to be able to, even though it's not a good quality picture, you can still, for example, find the detail, like this Mars picture, for example. I mean,
yeah,
fantastic. You see the
And
polar cap, you know.
you are doing it with the thing you have in your pockets.
Yeah.
That
And I
everyone has
I think
that
the
in your pocket.
I think the most beautiful picture is where there is a small place for your imagination to pop in and think, what else, what more could there be? What more could, if you don't see everything, that you can put your imagination on the board and think that your gray cells are beginning to spin.
Yes.
And you want to get more. You want to know more. That's the passion for me, that the picture has to be something, that there is something left to me to imagine.
So Max, you have a lot of pictures of planets near the moon. That's impressive. That's pretty good. You're really catching the right moments. That's awesome.
Yeah.
Yes, I do. I use the app Job Moons. That maybe when I'm working a little, I in the season of planetary images, I try to see when there are some moon passing by the surface of Jupiter, or maybe closest. But right now I'm trying to do planetary pictures with the planetary camera. It's a mono. It's very difficult. It's another thing to all of this, but encouraged to keep going. Okay.
Yes.
Yeah.
Yes.
Awesome. And to show to everyone this is amazing. Remember the day of Jupiter are 9 hours from here. In 1 hour goes the great red spot from here to here. So
oh yeah, high winds.
Exactly. And today Libby was saying that maybe when shows the Jupiter to some people with a telescope, you maybe don't see these movements because you can see it right now. But if you see right now, well, in a moment, but in 30 minutes, going to see it again, you see, oh, it moves. And this was said by Galileo Galilei.
Yes.
E persi moves.
You know, that's a very interesting, you know, just the rediscovery, right? I mean, knowing that, you know, hundreds of years ago, you know, with very primitive instruments, much less than our
yes.
4-inch Maxitoff, right? I mean, I mean, it's that's a premium. I mean, and to be able to see what they saw and kind of experience, rediscover it, right, for yourself. It's a wonderful feeling.
Well, this my sky from here in Chivilcoy, but now I have some. This is Mercury lights. That's why it's orange. Okay, but
oh, look at Orion. I love the angle. Yeah, it's southern hemisphere view. Yeah.
Yes, it's different. You know, when some people say me, yes, that's Orion. That's the belts of Orion. But where's the hell?
Exactly.
So
exactly.
no, the hell is here. No, but I see here the hell. No, but this is the sword. But I see this like an arm because I see it like that. And also the moon. The moon. When you see, well, this is some. Let me show you when I went this year to La Pampa to. Let me tell you a little story. This night, it was from Santa Rosa, La Pampa, where my girlfriend's mom lived there, and we went because her birthday. But days before it, no, the days after that, I want to see to take pictures in a place quietly, but without dangers and everything. So a friend of my girlfriend told me a place in the north, in a old road you can stay and everything. Okay, so I go with my gear, but I didn't realize I see a door open, a big door open, and it was in a university. I think maybe I go inside, nothing, anyone ask me anything, and not anyone bother me. So I put my gear, and when I start to guiding, the night comes. This friend who's going to be with me sent me a WhatsApp and told me, Maxi, here's a door closed. What? He sent me the photo of the door closed with a chain and everything. Oh God, I'm stuck here. I was in private property. I couldn't go anywhere. So I did the night. Yes, I found my girlfriend and told her, honey, I'm not going tonight with you. Maybe I can go to jail. But I have food, I have my car, I can be warm. But okay, so I took some pictures, and this is what I get that night. It really worth it. Let me show you with Zoom because I have here.
Nice.
Triplet.
Wow.
Yes. Beautiful.
Unbelievable.
Yeah.
I was with a half moon, digamos una gibbous moon, gibosa.
Yes.
because appears to 3 a.m. maybe more or less, and that's the little story. This is also that night, more early, the third helmet. I have it here.
You had the battery. You had enough battery, eh?
I have the 12 volts, 7 amps to connect the camera. I have the 6 volts, 11 amps to connect the mount, and I have the battery of the car to connect the computer to start guiding. So I have for all night electricity.
Awesome.
This is the nights. So this is the finally. Look at all the stars that I get. This was amazing.
Wow.
Wow. That's a hard object to take for
Where's
something.
Comet?
Yes,
Yeah.
and I think it was only 1 hour of stack.
Only, yeah.
Only 1 hour.
That's really good. What size? 30-second chunks?
No. This was the DCLR in 5 minutes.
5 minutes.
In 1 hour, yes, at ISO 800. And
excellent.
Then I do M1. Let me show you this.
What do you use for stacking?
I use this SS Deep Sky Stacker.
Yeah, that's what Cesar was using, right?
Yes.
Yeah, perfect.
This
wow.
M1.
Never seen it like that before. That's really neat. Yeah.
It's amazing, Nicola.
It is.
It's amazing. And well, the trio of Leo. And I did NGC 1368, but I didn't like the results. But okay, this is an issue of me, a little TOC, okay? And here passing by a satellite right there. You can see
see some of the fainter galaxies in the background. That's what's really neat. You see those ones there? A couple there. If you zoom in up there, Maxi.
Yes. Just a little.
There's ones to the right.
Yes.
And,
right
and I like the double bar on the galaxy. That's really nice.
Yes. When you see, maybe you see this.
Yeah, that's really nice. I like that.
And,
the core.
But in the exposition of pictures, it came out the rest of the galaxy.
Yes.
And here's another ones.
Yeah.
A little tiny, very far away. Here's maybe another. And
yes.
It was an amazing night. And see, this is the pictures crude. You can see the amp glow of the noise, but this is the night at 5 minutes. It was very, very good night.
Oh yeah, that's 5 minutes and it's not even blown out. That's amazing.
Exactly.
Good guiding. Good guiding.
Yeah, good guiding too. Yeah.
It's pinpoint.
Yeah, right on.
And was with the 200 F4 and too many lights goes on there. Well, this is that night, and this is M83. A few months ago, when I came back here, I was crying because okay, no, this is not.
You don't
the
even
same.
have to open them up.
Bring me back to Santa Rosa. No,
like a paint sample. Yeah.
Yes.
Brown paint sample.
Well, this is the sombrero. Trying to do it again.
Great. But you can see the data.
Yeah, but let me show you. The last weekend I did sombrero too. I cleaned up the stack because I didn't like it, but in this case was look at this. Now it's very, you can see sombrero here, but it's very.
This is the last night that you have to process.
Yes, exactly.
To be continued.
Let me show it. Sorry, Cesar, I'm going to show our chat.
I like this.
This is
Oh.
This is where I stuck it, but I didn't like how stuck it, so I deleted it, and I'm going to start again. But I want to see how it goes. The core, you can see, is very light, tightening. I don't want to do like that, but well, maybe I can try again. The stars, I like when the stars go right there, where I have some issues with the condemnation, like I explained today. So I fixed it. I figured it out. How was the problem? Okay. Sorry for the long chat.
No story at all. This is awesome. This is good stuff. Wow, really nice.
Well, this is an example that I calculate the size of the flares of the sun, taking the diameter of that day in Photoshop using a regla, ¿cómo se dice? A meter, for example, and doing the calculations of the picture and taking to the Earth size. So I figured out that give
how
me
many, yes, how many hertz?
You know,
one
you know what you should do, Maxi? You should all those pictures of the planets by the moon. You should take some of the planets and put them by the sun.
Yes.
Just
Yes.
for scale, right? I mean, you know, we obviously impossible picture, but at least it would give you some scale. That would be cool.
Yes, yes, I probably do that. Yes, I only have Venus, Mars, Jupiter, and Saturn. I don't have Neptune and Uranus because they are far away, and Mercury only when was the eclipse that we had in last year. Where was I saw here the 4th of November.
Oh, yes,
That's a good shot.
good shot. That's hard. Those are hard to take.
Yeah.
Yes.
Yes, I don't think maybe in 2013 too. No, yes, we can see here again, and Venus. No, I messed it up in 2012. I wasn't doing astronomy in those years, so maybe Cesar saw it. I don't know.
Sorry.
The passing by of Venus in 2012.
Yeah. And yes, I was in the Mercury transit in Mendoza in I don't know, 2013 maybe. I don't remember now. I have ready, if you like to see the picture of a 25 NGC 2516. If you like to see.
Yeah, any southern hemisphere object, Cesar.
Yes, yes, we have southern class. Yes. Let me show you where. Well, maybe here.
Oh,
it's a light, of course, because
nice. You got the color. Great.
Yes. No, I use it. I'm using for you, Max. Is the same that I tell you about Cyril, SIRIL. It's a free software that have the particularity of can make stacking process. And now the screen is with Photoshop because I took the curves of light a little more, but the 90% of the process was made with Cyril. This Cyril, I don't know how to pronounce
Cyril.
How do you say, Cameron?
I think it's Cyrodiil.
Cyrodiil. Oh, yeah.
Cyril,
Cyrodiil.
it's a good program.
Yeah.
It does a really good job, and it has a ready, how to say, macros, till example for DSLR.
Yes.
You just put the button and it does everything.
Sure. The color corrector.
Yes.
I put for the plate solve. I put the number of NGC and start to find and work properly, because the color corrector is the right color for this object.
Yes.
This is very interesting because of course that my objective is very cheap and the quality is horrible. It's not a Canon F teleobjective. If not, it's a single ultrasonic or something like that from the 90s, ran from Canon, a zoom objective 100 to 300. Have a lot of aberration. More of the first thing that I need to do is close a little the diaphragm at 7.1. Maybe it was much better if today I tried to use maybe the f-stop number 8, much better than 7, but because you can see some aberration here. It's horrible, but okay.
But that's it's it looks really good though. I
miss my 80 APO yes. Please, Scott.
Don't worry, Cesar. I feel I know you and I are in the same boat.
Yes. Scott, do you have a lot in this table, please?
He knows.
Only one. Yes. No. It's the emptiness of telescope is incredible. We receive telescope to repair all days, and come on. Today I prepare an 11 inches for to send to the client, to the customer. Sorry. And no. But it's maybe it's a punish for me. Use these cameras only.
So Cesar, this picture here, how did you get it? Is this the same picture you showed us earlier that was
yes. While we are talking, I put the picture that I show you. I stuck it when I start my presentation today.
Yeah.
Yesterday, really here. I'm finished to stack, and I show you. Do you remember I have opened actually the picture. Let me share the screen again.
Yeah, that'll be good before and after.
Yes, you do. Here you can see the side of the building.
Yeah.
And this. The first thing that normally I talk with the people is that don't remove the curve, the lights, the luminance with this program and use another one because it's a little complicated.
It is. Every time I try to play with this, it messes it up. So what you've done is, how did you make it so black? Like you took out it's so good. Like you took out all the light pollution.
Absolutely. I don't know if I'm sharing. Okay. But yes, it's the extraction for the background work really properly with Cyril, sorry, my pronunciation about this is a mistake for me. Have for example, one of the things that they have that you can write your own scripts. My son Agustin write me for me changing the things and script without flats, because with objective, I don't have flats. I need sometimes, but you know, it's not like a telescope. Well, I use this script for stacking. Tonight, like I don't make a great polar alignment. I prefer use Deep Sky Stacker, because Deep Sky Stacker is more, how do you say, forgive you your wrong alignments. If you have a no good alignments, normally Deep Sky Stacker say, okay, your alignments is wrong, but for today, I forgive you, and I stacking your horrible alignment pictures. Yeah, I totally. And yes, have an you know that have more. How do you say? Have more. I don't found the words in English, but have it's more like for wrong alignments. And if you have wider guided pictures, you can stack with serial or fixed inside that make a great work, especially serial, because serial is free. It's a free software, and fixed inside is wonderful, but the price is especially in Argentina, is really hard for the people. Because here 200 euros is, come on, it's a little.
It's a little expensive.
Yes.
Guys, I thank you for me. I have to go get some sleep before it's
okay, Pekka.
It's a dinner time. It's breakfast time is over already.
Okay.
So next is lunch time, but I'll take a nap.
Thank you, Pekka.
Okay,
thank you. It was a very nice episode today, and it was a pleasure to join. And thank you, Scott.
Thank you, Pekka.
Thank you.
To let me in.
Before you guys go, I am already planning for the next Global Star Party, which will be the 47th event. It will be in two parts. We will have an evening event like we're having now on the evening of the 25th of May. They'll start at 8 p.m. Central or 0100 UTC. And then then I will come back on very early in the morning. So I'm trying to predict that, but I think it's going to be about 3:30 in the morning Central, and which will give people time who want to live broadcast the the lunar eclipse that will happen that morning. So I'll send everyone that's in our group the information, and I'm hoping that those of you that might be listening in the audience that would like to partake in this, it is an early morning eclipse here in across the United States. I think it's an evening eclipse, in Asia. So if you're listening over there, that'd be cool. But it's the only total lunar eclipse of 2021, and it's a supermoon total eclipse. So it'll be special, and it should be beautiful.
Good, because we don't see it, so I like to see it.
Yeah.
Live.
Yeah. So
that would be very good.
Okay.
Excellent.
All right.
Okay. Excellent. Thanks, guys.
Thanks, everyone. Thanks for joining us, and we'll be back next week with the supermoon total lunar eclipse event. Take care.
Thanks, everyone.
Thanks, everyone. Have a good night.
Yeah.
Have a good one, all. Clear skies.
Clear skies.
Clear skies.
All right.